misconceptions. We've got truth in our possession. No room for doubt, no time to waste. It's time to put flat earth in its place.
Welcome everybody to Tuesday night. I hope you're ready for the Smackdown. Tonight we are featuring, at the request of both participants, Dr. Phil Bell versus Dick Wayne. And you may notice something missing, but we'll assume he's got caught up by using flat GPS instead of globe GPS. But in the meantime, welcome Professor Phil Bell. Oh, hold on.
There you go. Thank you. Thanks for having me, and thanks for doing this. We could have a bit of fun here. Actually, I'm hoping that there'll be a bit of education happening.
Well, that's usually the case when you're around.
Thank you. That's the purpose for doing this. Yeah, you know, I often join your show so that I can have a laugh, but this time I'm hoping that we can actually do some. I mean, not that you don't educate, you certainly do. I'd like to have a crack at it. Look, you know, a very good friend of mine who, you know, somebody who I interact a lot with was George. Do you remember George who passed away?
Yes, George Natchik, yeah.
Yes, that's right, yes. When I first came on the scene, George said to me, Phil, I got to tell you this. This is going to be a drug. It's going to keep you occupied for a long time. And at the end, it'll amount to nothing.
That's true.
You've got to realize this. Those people who you're arguing with are not interested in evidence
or truth. Okay, yeah, they don't want truth. They don't want evidence.
Yeah, they're not interested in evidence. They have a particular belief system, just like it would be like any religious one, and absolutely nothing will shake that, and no amount of evidence will work. But I don't want them. I want the people on the sidelines, and I want to try and curtail some of the scammers.
Yes.
Okay. Because those people there are actually fleecing vulnerable people, and that's what. And not only that, you know, they may affect people, young people who otherwise could do well in STEM.
Yeah.
So yes.
Yeah, I think there seems to be quite a few people in Flat Earth that are quite horrible, and so, you know, is it that Flat Earth makes them horrible, or is it that Flat Earth is a gillnet for horrible people? And I think mostly it's a gillnet for horrible people. Yeah. But I've seen people come in, enter Flat Earth, and then over time get to be bad people. Get worse and worse, because you have to not care about evidence. You have to, for Flat Earth, you have to just ignore reality and be fine. They have to be fine with not having a standard on not lying.
Well, yeah. Well, it seems to me that having looked at it now for quite some years, I can't believe that I can't believe I'm doing this for this many years. I'm ashamed to say that it's years.
Yeah.
Not a few weeks, not a few months. It's been years. Okay. And really what I see is that people get really, really angry if you actually point out to them that they're wrong, that they could be wrong. So even though they don't want to accept evidence, there's evidence you can't ignore. Okay, it doesn't matter. It doesn't. No matter what you think, you can't ignore the evidence because it's self-evident. So when you do point out those things like self-evident evidence like that, they get really angry because that hits them squarely in their belief system, and especially those people who are actually scamming the vulnerable people because they know that this is dangerous.
Yeah.
So I would, wherever I go, if I decide, oh, look, I'll pop in and say something, I'll get banned immediately.
Yeah, they don't. Yeah. It is interesting, the dynamics. So like the Awake Souls, Jason Laffenberg and Ronnie, whose channel is called Limitless. They Ronnie, let's see, Jason said some pretty horrible things while in the live chat of Will Duffy's final debate. And so I blocked him on the channel, and then he logged in with about 10 other sock accounts complaining about censorship. And I am currently at the very moment have been blocked on his channel for years, and not because I said anything mean. I said it was I believe it was a comment on one of their videos on 5G. I just gave them some corrective information. I have the background in that topic, so I gave them the background. They didn't like it, so I'm blocked on their channel. So the hypocrisy is amazing too. They don't like they pretend that they're against censorship, but few groups of people censor more than Flat Earth.
Yeah, exactly. Yeah, that's right. Anyway, hopefully we can catch some of the people who are genuinely sitting on the fence, and who thinking that they could be in a special place if they do fall into this flat Earth nonsense, and feel like they'll have friends, and it'll become a community, and they'll be part of that community. Because I imagine there's a lot of people who feel disaffected by the mainstream system. I mean, you aren't going to, if you left school when you were 14, you're probably not going to be in a group that discusses physics or anything like that, and you might want to. And you might feel intimidated by people who, maybe even have finished high school doing some physics. So one of the ways is to join a group that it doesn't matter, and the evidence doesn't matter. So you can feel special, and you can feel like something that literally thousands of years of knowledge.
Yeah,
meant nothing. All the great names. I mean, something? It's this lack of education that fails to appreciate these people. I mean, my personal hero, Sir Isaac Newton, probably, in my opinion, the greatest scientist that's ever lived, and probably will ever live. Completely unappreciated in what does it take for a 24-year-old or a 26-year-old to do what he did?
Yeah.
To invent the calculus, for God's sake.
Yeah,
that means absolutely nothing to uneducated people. But to educated people, you're thinking, how does a normal human being do this?
Yeah, when learning calculus, if you haven't learned calculus, people, when you go through learning calculus, you're like, oh wow, this is such. When you get to the end of it and really get to understand what is happening, because you don't get that when you're in the middle of it. When you're in the middle of it, you're like, what the heck is all of this delta or epsilon and delta neighborhood stuff? How is that right? But you get to the end, you're like, oh my goodness, how could I have done that in any other way? Don't know. You'd have to do it iteratively, right? You're looking, well, how do I get the area of this weird shape how do I get the area of it? Well, I don't know. I'm gonna have to just draw a box here that's approximate, and another box here that's approximate, and draw. Well, how many boxes am I going to draw so that I can be approximately correct? I don't know. It gets to be pretty cumbersome, and here he figured it out just sitting and pondering things.
Unbelievable. Just totally in awe of that.
Yeah.
And then figuring out that it's all of this stuff that's orbiting. It's the gravitation, and thinking how he put that together so that he said yes, the force is proportional to the masses divided by the square of the distance between them, and thought, coming up with that, and to this very day, you can't argue with it.
Yeah.
For any useful thing that you and I or anyone else would do on this planet, this works for us.
Huh. All right. Well, let me review a little bit of the email exchange here. So Dick had reached out to me about debating you, emailed, not in a reply to me, in an email responding to what I had said during a live stream, saying I should be able to make the 23rd around 9 p.m. Pacific time. No format, simple, in short, send me the link whenever. I will join around 9 p.m. Pacific Standard Time. Now, that was the first email. I emailed him back and forth because Phil, you wanted a different time. He wanted it, so it didn't quite line up. And in the end, I said, well, can we do 8 o'clock? And I sent an actual link, which is, and which the link is to timeanddate.com, and I'll send the actual link right here. There's the actual link I sent, and he responded shortly after saying, this should work fine for me. And Phil said, no problem for me either. So, and then so good. We got the time set, which was 17 minutes ago. And then, I said, I'll make a thumbnail for the video. Do either of you have a glamour shot or avatar you like? Dick, is this recent glamour shot good for you? And then the picture that's in the thumbnail.
Yeah.
And he replied in a typical smarmy Dick way about Craig, but he said, sure, go with whatever you like, whatever you want. The chat troll army YouTube employees will believe that pick you chose is me and run with it either way. Of course, we know that's not actually Dick Wayne. Dick Wayne, the one that's always the troll in our chat, doesn't have hair that magnificent. If you don't know what I'm talking about, check out the thumbnail. So we got Mallory's Asylum is here.
Oh, wow. Oh, my heart.
Mallory, you want to pop in and say hi? You could pop in and say hi. Icy Spin even made a custom animation for when Dick does show up, when and if. Okay. So we'll have to wait. Let's see.
I haven't seen Mallory around for quite a while. My candle is starting to dim. She sent me
a DM just today. She does want to come on soon. Currently am in school.
Oh. Okay.
Oh, I'm so excited. And yes, my English teacher shakes her head a lot at me. Okay. All right. Good. People. Mallory does want to come on sometime. So good. Not now. Okay.
That'll be fun. Yeah.
All good.
That'll be fun.
All good, Mallory. It'll be the most watched episode ever. No doubt. Professor PhD Tony says Newton may have been a genius, but Professor Phil Bell is way nicer.
Yeah.
So, all right. I don't know what's going on with Dick Wayne. I sent him an email just a little bit ago saying, I hope you're well. Here's the link again. Nothing. So my guess is that he didn't quite catch that difference in time. And
it's possible that he's waiting till 9 o'clock. So
9 Pacific, right? Which is what time here? It's 11 p.m. here. That's hours from now. He must not have looked.
Yeah, you sure maybe he thought 9 p.m. Central Time.
He couldn't have, because I sent this link right here. Yeah. This link here. Okay. I'll bring it up on screen for everybody to see. This is what I always do this with flat earthers, so there's no ambiguity, right? I'll ask them their time zone. Then I will I'll send them a link with their time zone in it here. So yeah, I don't need the advertisement. Make that go middle. Anyway. Here it comes. Oh, everybody in England, people in London that were wondering about the secret mission. I have sent out the invitation, should you choose to accept it. And at least one has so far. Some people got confused and thought I was saying that there's going to be a meetup that like I was going to be involved in. No, it was that I was going to make all of the people in London would then get an opportunity to meet each other and exchange emails back and forth. And then I said they could arrange a meetup amongst themselves. So that turned into, hey, a few different people saying, hey, I'd love to do a meetup in London. So if they choose to do that, I will inform all of you when that happens. So Dick Wayne is in the chat.
Oh, okay. Well,
Dick Wayne, where are you and why are you not in Zoom? Let me see here. But I'll pop this on screen. Here's the actual thing. Here, right? I got Pacific time, 6 p.m. Pacific. I got Minneapolis time, 8 p.m. And then Sydney time. Are you Sydney time, Phil?
Yes.
Okay. I guessed. I didn't know. So there you go, 11 a.m. So there it is. So where did Dick Wayne go? I don't see him in the chat here. Dick Wayne got a date with Rosie O'Donnell. He'll come later. I don't see him in the chat. I'm looking. No, he's not in the chat. Monkey Cat Pat Pat, why do you tease me like that?
Mm-hmm.
All right.
Michael, if you have got nothing else organized, I wanted to have a little chat with you about your trip to Antarctica.
Absolutely. Let me read. Okay. Let me read a couple of super chats while you prepare yourself. Rossi says, "Let's have a poll. I don't like Dick. I like Dick. I love Dick. I can't get enough Dick. Oh my gosh." All right, that poll. Yes. Poll. This is going to be the weirdest poll I think I've had on here, especially if people don't have context. And some people are not going to know how to answer. They're going to be so torn in so many ways. All right, there it is. There's the poll for everybody. Rossi's poll. Melodic Lyrics says, I guess it's another Tunes Day. It is. It is. Tim Davidson says, Newton invented calculus during the pandemic. Do you know how bored you'd have to be to invent calculus? He'd have to be driven to figure something out.
Yep, for
Right?
sure.
Alyssum says, love from Oz. Sadly, no time to watch this live. Looking forward to watching this on 2x speed tonight. No mercy for this short buzz flurf. Yes. Jim Daniels says, Dick came in briefly and said he would be here. Well, where is you, Dick? Lord Luminous Pooh says, sometimes I think I know you're reading my mind. Just in case. To scare him off, I see. Lord Illuminous Pooh said that. Okay. Evil Producer One says maybe Loretta Bobbitt took Dick. Could be. And then Hugh Jarvis says Professor Phil Bell is one of the greatest Jars souls ever.
I have got one of his T-shirts.
I've seen it.
And I wear it very proudly.
All right. Let's see. That's easy. Easy one for me. Okay. Anyway, go ahead with the questions.
Okay. All right. Well, first of all, before we do that, your poll. Now, I could answer this poll if you just used liberally the word "my" in it.
My.
I could answer that question, one of those questions. Then, yes.
Oh, if you could put my in there, yeah.
Yeah, put "my" in the sentence.
Yeah, you don't get that. Yeah.
In the phrase. If you do that, then I won't have a problem. If I didn't like it, that would be a problem.
Yeah. So
but just like this, I don't know.
the question is, Mallory, which one did you choose? All right, go ahead.
Yeah, there. Mallory, my candle is just getting weaker and weaker, but I'm still holding on to it.
All right, you got some questions.
Okay, yes. So that must have been a terrific, exciting time, for you to finally go down there. So, tell us, what's it feel like to step off the plane in this wilderness, if you were?
It was, well, we were cooking. We were hot already. So in the plane, right, we're in the plane for a little over 4 hours. And, we got on. It was comfortable weather in Punta Arenas. And then we were super comfortable in the plane. And they're like, we're going to turn off the heater in the plane so it cools down in here. Well, they did, but it didn't cool down that much. Then we put on the gear, like all the gear. So we had the big giant coats, we had the snow pants, we had the giant boots, not the lightweight boots that I bought that I owned, but the giant boots that we rented, and everything. And then we're like hauling all of the stuff with us off the plane, get off the plane at the tail of the plane, and walking down the stairs. It's super windy from the jet engine. Hello? They don't turn off the engine. Looks like Dick is in the house.
Yes.
They don't turn off the engine. So here we are, like just getting blasted by the snow, or by the wind. And then we get away from that. And then we just look around and you're like, it's snow everywhere. It's not actually snow. It's like little tiny ice crystals. And then we got in the vehicle thing. And they had the heater on in there, and we're all just cramped in there with all our stuff on. We couldn't take it off. And by the time we got to camp, like half an hour later, we're dying. It was so hot.
Hello?
I can imagine.
Hello?
Yeah, we can hear you.
We got you.
Richard, it's
Perfect, thank you.
All right, well, I can answer those questions later, I guess.
Yeah, let's carry on with that conversation later on. No, I've got plenty to ask you. Yeah.
All right, Dick Wayne is in the house. What happened? We were concerned.
Yeah, I bet. Sorry. This family comes first, and
of course,
something to take care of, and
all right.
Traffic, but I'm here.
All right. Well, okay. I've got just so everybody knows, I've got a special. Unless you're going to be on screen, you going to be on screen?
No, I'm not ready for that yet.
Okay. All right. Well, so I've got thanks to Icy Spin, a special animation custom made just for you. That I'll be putting on here in just a second. Let me just get it set here. All right. There we go. All right. Well, this is no format, so I'm going to mostly just to hand it over to you two to talk amongst yourselves.
Thank you, and nice to finally talk to you. So, Dick, do you want to be called Dick, or would you like me to call you Richard? Have you got a preference?
No preference. You do whatever you want.
Okay.
Maybe for YouTube purposes, call me Richard.
Okay, I'll call you Richard. That's all right. That works for me. So Richard, thank you for coming to have this discussion. I think it's an important discussion that we have this, and importantly, I think that we should have a cordial discussion, because I think we can do that with just having a chat about stuff that we that we believe in, and just trying to work through that. But now, I just wanted to say at the outset that I'm not particularly interested in going down the complicated rabbit holes, especially concepts in physics that because to be frank, you don't have the foundational scaffolding for us to discuss that in any great depth. But not to say that I won't discuss some of it at a surface level. So perhaps if we confine ourselves to matters that really rest on common sense, okay, rather than
speaking my language.
Oh, that's excellent. That's great. And of course that works in your favor, Richard, because given this breathtaking level of confidence that you display, okay, one can only assume that it's underpinned by equally staggering edifice of common sense. I'm looking forward to
logic and common sense.
That's it. Yeah, I think that's it. And so Richard, why do you in spite of the Earth, people agreeing that the Earth is a sphere for more than 2,500 years, why would you join this group that says that Earth is not, that it's flat?
Well, first, there's no honest evidence that, everyone agreed that it's been a globe for X amount of years. I've seen evidence to the contrary. I've seen newspaper articles from the early 1900s where parents were upset that teachers were trying to teach the globe to their kids. So upset that they wanted the teacher thrown in jail. So starting there and saying, it's been proven thousands of years ago. No, I don't think either one of us can stand on that.
So Richard, when I said that it's been, thousands of years ago, it wasn't that this was from normal people, who wander down the street who, have any questionable education. We're talking about some of the most brilliant mathematicians that have ever lived. We're talking about people like Pythagoras.
Well,
we're talking about the philosopher. We're talking about some of the greatest minds all the way back then. You think those people would write what they did and talk about the Earth being a globe if this was just fanciful? In other words, it wasn't true. Do you think they would know?
Absolutely. People do lie, you know that, right?
But this is a lie from 2,000 years worth of lies. Every single one of them.
So a group of people got together and made up stories about what the Earth is.
Well, they didn't get together because it's century after century after century. Different people.
Well, I can't go there because you weren't there. I wasn't there. No one alive was there. So just saying it like it is set in stone fact, I can't go there. I'm sorry. Logic tells me I can't go there. I have to rely on me, my personal experience. One of my favorite quotes of all time, it is my favorite quote, is listen to everyone, read everything, believe nothing you cannot verify for yourself.
I mean, that is really a horrible quote, actually, because
What makes it horrible?
It discounts so many things. For instance, do you think you could personally verify that that water is made out of hydrogen and oxygen? Do you think you could do that?
No.
Exactly.
Wouldn't say.
You see my point? You see my point? You can't verify that personally.
I get the point,
but there's lots of people who can.
I still don't. I don't care what makes up water. To be honest, it doesn't change the physicality of it, how it behaves in nature.
Just
you know
an
what
example.
I mean there?
Yeah, sure. It's just an example I'm just pointing out water as an example. I could point to almost anything. I could point to ammonia gas. I could point to carbon dioxide. I could point to just about anything and ask you the same question. In other words, do you know? Can you verify that carbon dioxide is made out of a carbon atom and 2 oxygen atoms? Can you verify that? And of course, the answer from you will be no, you can't.
Like 99% of the population, I would say. No, they can't.
Oh, look, that you could be quite right about that number. But you know the other 1%, which also includes me, I could show you. I can verify that carbon dioxide is made out of atom of carbon and 2 atoms of oxygen. I can do that. Just like back then, those brilliant mathematicians, people like Pythagoras, like Euclid, those people who gave us the mathematics that we currently rely on, and much later on, you know, Sir Isaac Newton. You know, these people.
I won't agree with you
in that. They were in the 1%. You know, of those people who could verify those things.
They also have a lot of ties to, well, Newton especially, to the secret societies, if you want to call them that, the Freemasons, the Jesuits.
Why would that have any? Why would that have any bearing on his on his discovery?
You don't think that shapes how he thinks?
Hold on. Can I ask a question quick?
Sure.
Pardon me?
Can I ask a quick question?
Yeah.
Oh, go ahead. You guys, so, like I say, go ahead.
So you said that if you can't verify it yourself, you don't believe it. And then you said something that you didn't verify yourself about Newton. I'm just pointing that out. That's all.
But your mic is a little low to me. I can hear Phil just fine, but yours is a little low. Just for future.
Did you catch that? I could fix it, but did you catch?
Yeah, no, I heard you. Yeah.
Okay.
Yeah.
So how do you justify that dual standard of evidence you just?
I have verified it for myself by reading the information myself, hearing the information myself.
But you said that's not an acceptable way to verify things. I didn't say
that wasn't acceptable. Believing is where it comes in. I believe the information I've read. I believe the things I've heard because they make logical sense to me. I'm not here to push it on you guys, but my problem with this whole globe nonsense is it is pushed on us so hard, and it is fought against since it's, you know, if you want to call it, since, you know, the early YouTube days of Flat Earth and nothing has been more fought against than the idea that, hey, maybe the Earth isn't what we've been told since childhood, because everyone here in your chat, you, Phil, we've all lived under, we're all born into it's a globe, no more questions.
Okay,
Do you
well,
agree?
well, put it this way. Look, I agree in part to some of the things you say, but it's definitely is a globe, and this is why we're here. We're here to discuss because you said that the reason you think, I mean, you think the Earth is flat because you must have some evidence to attach your belief system to that. Would you agree?
Of course. I have my everyday experiences in nature.
Okay, so what
all the flat Earth really did for me was made me pay attention, made me actually question the globe. Is the Earth actually a globe? And then I go looking, and for 12, 13 years now, I have not found any physical evidence. It goes against everything I observe every day of my life. I go outside and I observe the sun, the moon, and the stars circling above and around Earth. I don't just go, you know what? I think the Earth is spinning, and those things are relatively, as you guys like to say, stationary.
But
why would you
say
what would even lead me to go there?
But you do say you think the Earth is flat, and then just based on that, you do say that, don't you? Without inquiry.
It matches what I see and experience every day. Planar, motionless foundation.
Well,
the sun, the moon, and the stars observably every second of every day since humans have been here circle above and around us.
So would you say that,
with that?
No, would you say that you're a rational person?
Absolutely.
Oh, that's good, because that's where I want to take this. I'm counting on you being a rational person, and I'm counting on you saying, so when I show you something, you'll look at it seriously, and you'll say, right, okay, I'll look at that from a common sense point of view. That's why I pointed out, you come across very confident, and as I said before, that's obviously underpinned by a great deal of common sense, I would think. I
am absolutely confident that the Earth is motionless and planar. Yeah, planar foundations.
No. Obviously, otherwise you wouldn't be here. Discussing that with me and asserting that the Earth is flat. If you didn't, so I appreciate that's what you think. So one of the ways to address this is, let's try and get on the same page to some degree, so that we're not arguing about every single thing, okay? And we're not in disagreement about everything. It would be nice if we could, because you've asked me a number of times, do I agree and stuff like that, that's a good thing, actually, all right? Because what we're trying to do is try and narrow our differences.
Right.
So that we can then focus on the, be more focused about what makes our belief systems different. Okay. So why don't we start with that?
You guys, just like I push you guys for definitions all the time. Sure. If we can't clearly and simply define and agree on what the definition of a word is, we can do nothing but argue. Right?
Okay. Sure. All right. So when you say to yourself that the Earth is flat, is there some picture that comes in your mind that and you think, I mean, if you say to me the Earth, I immediately put together my knowledge that I already have, my experiences, all the mathematics that I know, all the physics that I know, I put that all together. And when you say to me, the Earth, I immediately think about a globe. What do you think about? What comes into your mind? What's in your mind's eye when you say that the Earth is flat? What comes in your mind's eye?
I would have to say biblical depictions of it. A disc
Well, help me.
surrounded, or a disc in a plane. I don't know, obviously, and I may never know. I can accept this, whatever.
Well,
But yeah,
so
I would say a dome
a disc,
covering
a
covering a
dome
planar
covering a disc.
foundation.
Okay, I accept that. So because I don't want to build straw men for you to burn. You know, I prefer to. I want, this is valuable time
But
for
I mean,
me. Okay?
sorry.
And so I
sorry.
want to use it in a very useful way. Okay. All right. So, all right. So what I'm going to do is I'm going to go through a bunch of slides with you. All right, and then we'll talk about them as we go through them. All right, and let's see if we can come to some common agreement. Now, before we do that, though, when we talk about like, you still haven't told me what you think the Earth looks like from your mind's eye. So, but you have iterated that you think that
Just let me stop you right there for a second.
Yeah.
When you say, just come up to me and say, Earth, what do I think of immediately?
Mm-hmm.
I think of nature. I think of mountains. I think of the ocean. I think of animals. I think of people. That's what I think of. I don't think of, I don't know what you would say, like you were, I think it's a ball.
All right. Well, your mind.
I like to say nature first.
Okay. So listen for these words. Okay. And then tell me what you think. Okay. The shape of the Earth. What came into your mind when I said that?
Again, planar foundation with topography on it.
Just
Picture a tabletop and build a model train set, if you want to put it as simple as I can.
Sure. Now,
Lego.
That part of the experience of all of us is that we travel on this Earth, right?
Yes, of course.
We use common things like GPS. I have that in my car.
Mm-hmm.
When I jump in my car and I say, take me home, wherever I am, it does it. It draws a map, knows my GPS
I've been led
location.
astray by it before myself, but all that stuff is given to us, though. You had no hand in creating that system of navigation. You had no hand in the measurements they tell you is going on. You personally. So in the end of the day, the bottom line, you are still relying on other people. I can't measure the Earth myself. The logistics involved is just insane. I don't think anyone can honestly measure the size of the Earth accurately, physically.
So the Earth's not
the logistics involved are just, the logistics involved are just too much. And how do you physically accurately measure distances over oceans?
Just for reference, I've measured the Earth 3 times, but anyway, keep going.
Okay. All right. So you have an iPhone or something like that? Have you got a phone with GPS on it? Do you have one of those?
Yeah, I've never turned it on the phone. I navigate. I use the roads that are provided to me.
Sure, but you obviously use navigation, don't you? You have done that before on your phone.
I have used early GPS units in vehicles.
Sure. Okay, that's good. All right. So if it says that you're 50 meters away, or 100 meters, or a kilometer away from somewhere, and you drive that 50 meters or 100 meters or a kilometer, it actually turns out to be right.
Okay.
Isn't it? Doesn't it?
Well, I don't know. I didn't Again, I didn't physically.
Why does it? So
I
why
didn't
does
go,
it matter?
oh, I'm 5 kilometers away. Let me get something. Then let's verify this. Again, 99% of the people haven't. Don't do this. They don't think about that stuff on a day-to-day.
But you could, couldn't you? It's just you and me here, all right? You could. You said you were a rational person, and I take that at face value. So you could get your GPS out. You could get in your car and use the odometer to measure the distance. Say drive for 10 kilometers. Get your GPS out and see if that matches. Couldn't you? You could do that.
I don't know. First, I would have to travel in a straight line. The only way to get an accurate distance of anything is straight lines. Straight lines. No curves, no arcs, no great circles. Straight lines.
Are you telling me that if I lived on a hill, which I do, I wouldn't be able to know the distance from the bottom of the hill to the top of the hill where I live?
No, I'm saying, yeah, you could figure it out.
I could use my GPS to do that too.
Flip a meter stick do it that way. Sure, why not?
Well, so why can't I? So why can't I measure something that's not a straight line?
I didn't say you can't measure. I said for a true accurate measurement of a distance to something, point A to point B, is a straight line. What is the shortest path between any 2 points? A straight line. That is the accurate distance. Do you disagree?
I'm not disagreeing. I'm just trying to say to you. I just want to know why I can't do that if I live up a hill.
I'm not saying you can. But
all right, good.
So
we're getting on this bit slowly.
And then what? You're going to say, oh, well, look, it matches what they tell me the ball is. So
there's no they. There's no they. It's this instrument, which is the GPS receiver, tells me how far I went.
Yes. And who was that instrument programmed and designed by?
It doesn't matter. It works. I can't argue with it. It wouldn't matter. It wouldn't matter who invented it or what the code is inside. When I use it, it works.
So what? Again, what is its purpose? It is designed to work. But you're telling me the people that did it couldn't do it on something that was motionless and planar? It has to be a globe?
Nothing. We're not talking about that now. We're just talking about
rational. That's not rational.
No. Can you just try and stick to the topic, please, Richard? Okay. So all I'm trying to establish, like I said to you when we first started, we're trying to get on the same page. So I need you to agree or either disagree that the GPS can tell us how far we went. Great. That's really all of that amounted to you saying those 2 words. Okay, excellent. All right. Now, tell me something else that let's see if we can do this. You also, do you agree that celestial navigation works? That people who use celestial navigation, I mean, assuming the Earth is flat, if you think the Earth is flat, the celestial navigation works, then you obviously think that, don't you?
Yep.
Okay. All right, and that's probably a good segue into me sharing something with you. Okay. All right, so I'm going to share this. Hopefully, this works as well as it did when I put it up there for Michael. Okay, you can see that that's my assertion. The Earth is not measured flat. Okay.
Yeah, that's what
now, I was going to play something because I wanted you to hear something by somebody who does say that the Earth is measured flat. He says that a lot. Okay, and I wanted to see if you agree with it. So perhaps later
I
on
don't
during
want to
this
hear. I'm not
discussion-
interested in Oakley.
Okay, so do you think Earth is measured flat? Do you think he's right? Do you think what he says
I
is
think
right?
all measurements start with a flat baseline and use flat baselines, straight lines. Yes.
So if you think somebody says, I've measured a flat baseline to put it like that. I have a flat baseline. Do you think that they're entitled to say that the whole Earth is measured flat? Or do you think that, would you agree with that, or that's irrational?
That the Earth is measured flat.
Yeah. Do you
I
think?
can't
Do you think
agree with it because I don't understand the question, to be honest.
Well, no. It's very simple. He and many other people, that's Oakley and many other people, will say stuff like Earth is measured flat. Okay. Now, and they're basing that on their understanding that they want to take an angle of elevation, and therefore they want a horizontal attitude, and then take an elevation reading from that. Okay, and they're saying because they are assuming that this horizontal attitude is flat, therefore the whole Earth is flat. And so they make the assertion that the Earth is measured flat, as if somebody measured the whole Earth and found that it was flat. Do you agree with that? Do you agree with that?
No.
Do you think that's true?
No.
Great. We're getting
Where
there.
I come from is it is built on a planar foundation, absolutely. Because what do you know, what is the strongest foundation? As perfectly flat and level and stationary as you can get. You can build amazing structures on top of that. So where I come from is it's a planar foundation with topography.
Good. So I'm not building a straw man for you then. All right. You actually think it's nonsense. So well, that's one in you're going up in my estimation there. Okay. Well done. Okay. So let's carry on. All right. Now, because of that, so what we'll do is, because often people say, well, if you ask a person who thinks the Earth is flat, have you got a model for that? They'll say no, they don't. They don't have a model, but of course they do, because they said the Earth is flat. So they may have an inadequate model, they may have a rudimentary model, but they certainly do. Just by saying that the Earth is flat, automatically gives them that model. Okay, so let's go through this, and then let's just see if we can agree from place to place, just so that I don't set up this straw man for you. Okay, all right. So we're going to go. Let's hope this works. Okay. Okay. Can't wait a bit. I think that was the second slide. All right. I have to be mindful that there's some lag here. All right. All right. So let's have a look at this over here, and I'll just describe what we're seeing. Okay. So we're making an assumption here that the Earth is flat. Like you won't have a problem with that, obviously. And if you can see from here, this is at 45 degrees latitude. Okay. All right. So 45 degrees latitude. I guess you know that Polaris, the North Star, is pretty much above the North Pole. Would you agree with that part of it? And that in order to know that we're at 45 degrees latitude, we could just look at, we could take an elevation angle from essentially what you call your flat Earth, from that to the star, to the Polaris, and we see that it's 45 degrees, so therefore we're at 45 degrees latitude. Do you agree with that part of it?
Sure.
Okay, excellent. All right, so you can see over here, we've got, I've picked out 4 cities. Minneapolis, United States. We've got Bordeaux in France. We've got Sugbata in Mongolia, and we've got somewhere in the North Pacific. We've got all these places at 45 degrees. They're in different parts of the world. Okay, they're different parts of flat Earth, and they all look up and see Polaris, and they see Polaris at 45 degrees. So they all agree that though the people in those places would then agree that they are at 45 degrees latitude. Are we on the same page?
They all look up and they use the same method to measure a 45-degree angle to Polaris.
Yeah, sure. Yeah. So in other words, that happens from different parts of the world, right? So in other words, somebody in Mongolia is really opposite somebody in Minneapolis. Somebody in their ship in the North Pacific is opposite to somebody in Bordeaux.
Of course.
Okay, so they're at 45 degrees on opposite sides of the world, and between the North Pole and them, it's flat. So according to your to this model that we're putting together.
Yeah.
Okay. All right. Good. All right. We're on the same page. So my slide wasn't a waste. All right, let's see if I can get another one to go up. Well, if we have a look over here, I suppose you know about the Tropic of Cancer, do you?
Yeah, I guess.
What do you know what's special about it? That particular latitude?
It should have significance, sure.
Yeah, but why? Well, do you know why? I'm not. It's not a got you. I'm just.
I would guess.
I just want to be on the same page with you.
The sun, at some point, to an observer, does something special. Or
all
something,
right, well,
or something, yeah, repeatable. You know what I mean? Like a cycle.
Okay, so if I said to you that would be the extent to which the sun would, its north and north, the GP of the sun would reach north. That would be the extent of it. It wouldn't go any closer than 23.
Okay,
yeah. Do you agree with that? Yeah.
Yeah, I can. Yeah.
Okay, and let's just have a look at our diagram. We've got Ahmedabad in India. We've got Wake Island that belongs to the United States. So that'll be in the South Pacific. We've got San Luis Potosí in Mexico and Dakhla in the Sahara, in the Western Sahara. All these are sitting on this latitude. So if they were looking at Polaris with say an inclinometer, they would see that the angle of elevation would be 23.4 degrees. Well, it would be 66.6 degrees, and yeah.
Sure.
Okay. If they were at the Tropic of Cancer. Okay. All right. Okay. Good. We're still on the same page. That's fantastic. We're doing really well. Now here we are at zero. So we're at the equator. And I don't mind sharing with you, I was born very, very close to the equator. Okay. All right. And in fact, Mount Kenya, I was very, very, very close to that. Now that's pretty much. There's actually a hotel there, which is you could straddle the equator. So in other words, you could have one hand reaching out into the southern hemisphere and the other reaching into the northern hemisphere. How cool is that?
Yeah, right on.
All right. Now, along that, we have also on the equator, or very close to it, is Palu, Indonesia. Okay, and then I think it's okay. There we go. The Marquesas Islands, which belongs to France, also in the South Pacific. Well, in the South Pacific. Then we've got Boca de Marapi in Brazil. All of these on the equator. So we both understand what the equator is. And the significance of that is that twice a year, in fact, we've just passed it, not just a couple of days ago. Just a couple of days ago, for me anyway, for you, the sun was actually at the equator. So that's where its GP was, along the equator.
The right shore.
Okay. All right. So we're agreeing with that, and looking at that, that's going to be 6,219 miles away from the North Pole. Okay, because
Sorry, what?
because it's 6,219 miles from the North Pole, and we know this. We know this because we know that each time that for every degree that we move away from the North Pole, that represents 69.1 miles. Okay, if you move away another degree, that's another 69.1 miles, and so on.
Yeah.
Okay, great.
See a problem with this.
Yeah, excellent. No, I'm hoping that there isn't a problem. All right. Okay. So here we are at 0 degrees.
If all those points are using the same methods, same tools to make these measurements,
that's good.
questions.
In other words, they're on other sides of the world. So now we agree. We now have two concentric. We've got 45 degrees. We've got 23.4 degrees. We've got 0. Okay, so the Tropic of Cancer, and then 0. And we all agree that these are concentric circles around the North Pole so far. We've okay, excellent. So we're getting there. Okay, so now we go beyond that. So we've got it's actually 66 degrees. Of elevation, but we're now at 23.4 degrees south. Okay, so we've now gone beyond the equator, and we're now in what we call the southern hemisphere. We call it the southern hemisphere because the equator is the boundary between the northern hemisphere and the southern hemisphere. I think even you would agree with that. Let's have a look at
Not exactly, but
all right. Let's clear that up. Why not exactly?
just the wording you use. But I can agree that the equator is the line where they separate north and south.
Okay, that's what I meant. Okay, so let's agree with that. Okay, good. All right, so over here along so this is now called the Tropic of Capricorn, this particular location. So the sun's GP will be over this location, the Tropic of Capricorn, and so the people from São Paulo in Brazil would see it. The people from Dubai in islands in France in the Pacific, they'd see it. The Australians in Alice Springs would see it, and the South Africans at Polokwane in South Africa, which is very close to where Flatzoid comes from, actually. They would see it. So in other words, in December, it'd be very, very hot over there because the sun is directly overhead at noon in these locations. Okay, that's along the Tropic. And the other special thing about this Tropic of Capricorn, it's the sudden extent to which the sun goes. The sun doesn't go beyond the Tropic of Capricorn. It doesn't get closer to the south, to the Antarctica. Okay. this is it. So it travels between here, the Tropic of Capricorn, and then through the year, through the season, goes up to the equator and then goes on to the Tropic of Cancer. So in December, it'll be at the Tropic of Capricorn. The Tropic of Capricorn will be in the south, it's further extent of the south, and then in June, in June, half a year later, it'll be doing the same thing at the Tropic of Cancer. I presume we're still in agreement.
Yeah.
We now have had a look at how many we've had. A look at 45 degrees. We've had a look at the Tropic of Cancer. We've had a look at the equator. We've had a look at the Tropic of Capricorn. We now have 4 concentric circles.
Mm-hmm.
Okay. So let's move on. Oh, press the wrong button there. Stop that. Okay. Here we go. So here now there's the last one I haven't spoken about. Actually, this one, just in case I've missed one. No, that was right. Okay, so here are the concentric circles. The last one I haven't mentioned, and I'll mention it now, and that's if we keep going, we'll eventually get to 90 degrees south. Okay, so we're at the North Pole, and if we keep going, we'll end up at 90 degrees south. Again, another concentric circle. So all the people, this is flat Earth I'm talking about, we'll be looking straight up ahead. We'll see the sun directly overhead. If they have a look at their GPS, they see, oh, I'm at 90 degrees south. Look straight up, I'll see the sun at noon. Okay, presuming that's what would happen on flat Earth, yeah. So we now have concentric circles. Now, 90 degrees south is as far as it goes. I mean, is there 110 degrees south?
There could be, if you wanted it to be.
Yeah, so I don't see any. So how would you do that? What would you do to get 110 degrees south?
Just keep traveling south. Won't the degrees keep increasing or decreasing?
It would be 110 degrees with reference to what? I mean, when we talk about degrees, you agree it's with reference to something, right?
Yeah, the object you're looking at.
Yeah, but it's with there's another reference. You can't get an angle without 2 references, could you?
Well, what's your other reference?
I'm asking you. 110 degrees south. What's the other reference? You said we could get.
Maybe I misunderstood where you were going. Anyway.
So in other words, 90 degrees south is either the limit or you can go further. Okay, than 90 degrees south. But then you'd be calling it, say, 110 degrees south. And you say, you'd be calling that, why would you call it 110 degrees south? 110 degrees with reference to what? How can we verify that it's 110?
With reference to, I don't know, 180?
Are you, sorry, I'm not getting this through. You've arrived at 90 degrees south. Okay, this is flat Earth we're talking about. You've arrived there and you know that you're at 90 degrees south because you've got a GPS. And you know that you look straight up and you see the sun. You know that you're at 90 degrees south, okay? No question. It's easy, all right?
Yeah, okay. You look up, you see the sun right above you. You're at a place on Earth, okay?
Okay, but now you want to go to 110. How do you get to know? How will you know on flat Earth whether you're at 110?
Again, wouldn't you just keep going in the same direction in a straight line?
Sure, but how will you know that you're at 100?
The object is now going the opposite way. I don't know, call it counting down.
Counting down?
I
What do you
don't
mean?
get- We're talking about 180 degrees here, forward and back. Are we not?
No.
The sun is right above me. If I keep going forward, if I keep forward, right? We can agree on forward, okay? I keep going forward. That's how I got to my 90 degrees and the sun right above me, right?
Let's do this slowly, all right? When you were at Capricorn, you took out your sextant. We just imagine this. You to take out your sextant and you measured it and you say, oh, that's I know that's going to be 66 degrees, 66.6 degrees. I look at that and that's what I get. And then you go further south and you perhaps you go to the you go to the 60th parallel, which is near, okay, and you look up at that, so you know that's 30, and you go further down until you reach 90. You know, until you reach this 90 degrees, you look up.
Okay, I stop.
Now, when you hang on, this one. Let me finish.
No, just stop for a second, please.
Yeah.
I'm at the point now where I'm standing at a place on Earth. I look up and the sun is right above my head. Yes or no?
Yeah, it's when you at 90 degrees. Yeah, good. You're beyond Capricorn. You're not at Capricorn anymore. Okay, though. All right, you've gone further south.
Wherever I am, yes. Okay.
Okay, so you're further south. You're at 90 degrees. You can tell from your GPS that you're at 90 degrees as well. By the way, okay.
No, I can tell from looking up and seeing the sun right above my head.
But you can tell from your GPS tells you that too, right?
Well, hold on. The sun's not right above your head at 90 south ever.
Yeah. Okay.
Right. It's never straight
No,
up.
it
I just
wouldn't
want
be.
to. I think you might have been missing that, Phil.
Okay. Sure. Okay. All right. So, well, you know that you're at 90 degrees at south. You're right. You're quite right. Yeah. I've misspoken there. It wouldn't be right above your head. You'd be at south and you'd see the sun at Capricorn. The sun would be at Capricorn, so it would be. You'd have to look up at it. There'll be your angle of elevation. You'd have a look at it. So no, it wouldn't be above your head. Okay. But your GPS would tell you that you're at 90 degrees south. Do you agree with that?
Sure. Yes.
Okay, all right. That's all I wanted to get on. Yes, so I've misspoken. You definitely won't be at south seeing the sun above your head. That can never happen. The sun never gets past Capricorn. Okay.
Sure.
Okay, good. All right. Okay. All right. Okay. Let's go. How is what we've just looked any different to this?
What?
How is what we've just gone through any different to this? And Michael, thanks for pointing that out. I don't know what made me think that.
Yeah.
Yeah. Okay. All right. Okay. How is what we've just come across? In other words, from the North Pole to the Tropic of Cancer, to the 45 degrees Tropic of Cancer, equator, and then finally 90 degrees. How is it different to this?
I'd say it isn't, other than
Wonderful.
I don't know. There's a lot more detail now. You're adding a lot more information.
Wonderful. Okay. Wonderful. Okay, that's good. All right. So just to recap, the sun isn't over your head at 90 degrees. I just want to recap that. Okay. All right. So in other words, because the sun can only go up to the Tropic of Capricorn. So if you're further away, then you would have to, you'd have to look north pretty much to see the sun if you're on flat Earth, right?
Okay, to simplify it, the sun has limits into which it goes to the extent at which its circuit is, okay?
Mm-hmm.
Is it that simple?
Yes, yeah, exactly. So in other words, between Cancer and Capricorn, yeah, exactly.
Almost
Right,
as if it
so
was
the main thing is
created to
that
follow
we
its
agree that
circuit.
we agree that if we all those places that I pointed out to you, right, there are people there. They would have their GPS system, and it would tell them where they are. Okay. All right. So what I pointed out to you actually matches this thing. This is pretty much it. If there is another version that matches all the stuff that we've spoken about, I'd be glad to hear it.
Okay.
So it matches this thing. Okay. All right. Good. That's all I wanted to make sure that we're on the same page with that too. Okay. So when people say the AE map is wrong for flat Earth, they're wrong, aren't they?
I don't know. I don't.
Flat
really care
earthers
what
who
they
say
about.
the flat earthers who say that's not our model, that's not us, that's not flat Earth. They're wrong, aren't they?
It's their opinion. I'm not going to call it right or wrong.
No, but it's your opinion too, Richard.
No, it isn't.
But Richard, we just
I wouldn't
agreed
make that
there's
claim.
no substantive difference. You said you were rational, so let's work on that. You agreed that what you saw with the concentric circles matches this.
Yes, you
agreed
can
with
draw
that?
concentric circles over a plane.
Right. So this matches flat Earth, right?
It matches observations. Put it that way.
Which is flat Earth, right?
No, I don't. First, that term's been weaponized. I don't like to use it.
Planar Earth, would you prefer that?
Earth.
Yeah, well, we're describing whether it's going to be a sphere or whether it's going to be flat or some other shape.
Well,
You've agreed up and
until it's proven otherwise physically, it's Earth.
but you said it had a flat baseline. You said all the people who were from the equator looking towards Polaris, they were looking across a flat baseline. You said that. Why are we going back on this? We got so far so well.
I'm not going back on it.
So you agree that it's a flat
different
baseline?
points of the Earth that look up and measure the same distance to the same object.
And that distance is over flat, isn't it?
They used imaginary, invisible, whatever you want to call them, straight lines to make those measurements and angles, did they not?
The baseline is Earth measured flat or not? Is it a flat baseline between the GP of
What is a not flat measurement? How do you
globe.
take a measurement, Phil? This is why you guys try and overcomplicate everything, and it gets so frustrating to even, you want to talk about being reasonable, rational, logical?
I'm trying to simplify it, Richard.
No, you're not. You're overcomplicating it.
No.
Because it's like something inside you guys just can't say flat, can't say straight. Because on a ball, flat and straight are impossible.
Forget the ball.
How are those measurements taken, Bill?
I'm just talking about this, Richard. Those people who were at 45 degrees, remember, there were 4 of them? 4 places?
Again,
they're all looking up.
Bill, Les, I get it. I do get it.
What do you get? Do you tell me what you get so that I can see if you do?
So
actually.
do you think, looking at what I'm looking at right now, top down, do you think I can't put 4 people at random spots, all opposite each other, looking at each other basically, and have them looking up and measuring the same angle to a point in the sky?
Yeah, good, great. So so you know that the GP then of the GP of Polaris is roughly at the North Pole, right? And
It's above a point on Earth, yes.
Yeah, okay. And between the North Pole and where those people are standing, let's say in Minneapolis, it's flat.
No, it isn't. There is mountains, rivers, valleys.
No, removing it's, let's call it, it's mean.
Hills,
It's mean topography is
potholes.
flat. It's mean topography is flat. If you want to be pedantic.
Its foundation is flat.
Okay.
Well, here, you know what I just thought of? You asked me earlier, what do I think of when I think of Earth? I think of it as the Bible described, like clay pressed under a seal.
Okay. So between the North Pole and Minneapolis, it's flat. Okay. So in other words, it's not a sphere, right?
Again, yes.
Okay. Well, that's all I want to know.
It's
right,
not
good.
a sphere.
And then between 45 degrees and the equator, still flat.
Yes.
And between the equator and the Tropic of Capricorn, still flat.
Yes, Phil.
And between the Tropic of Capricorn and 90 degrees, still flat. So flat all the way.
That's the right word you want to use? Yes. Okay, I can agree with that.
Okay, I just want to make... So there's no substantive difference between those, what we looked at, how we built, putting those circles, and this that we're looking at right at the minute. There's no difference, really.
Major substantial differences.
What?
Because now you're adding that is the exact shape and measurements of all the continents and that kind of stuff. And that we're never going to agree on.
But where did it go wrong?
What do you mean? Where did it go wrong? This is what I mean. I don't get it. We're in agreement, Phil. Can I put 4 points on what we're looking at right now and all have them look up at the same fucking thing in the sky that's stationary and measure a 45-degree angle? Yes or no?
If you're at 45 degrees and you look
yes
at
or no,
it'll be. I don't understand your question. So
are you serious? Draw put 4 dots on that map anywhere you want.
Yeah, sure.
And can I not have them all measure a 45-degree angle? Well, sorry, no.
You put them all at 45.
Yes. Again,
you put 4 people at 45 degrees.
4 people, and they all look up. They use the same method. They use the same instrument.
They'll all
look
get
at
the same
point of light in the sky, and they say, okay, I measured a 45-degree angle. I did my best to take a horizontal baseline. I looked and I measured the angle.
Yeah, so this
can that be done? Can that not happen on what we're looking at right now? Yes or no?
Yes.
Okay.
Good. Right. We're in agreement, and that would happen for the equator, and that would happen. And obviously, you can't look at Polaris
anywhere on Earth. Anywhere you can stand and set up your equipment and make the measure.
You can't see Polaris from the equator, can you? Unless you're very high up.
Okay, as long as you can all see the same point of, and all agree that point of light, that's stationary.
And you agree that there's a relationship between traveling 69 degrees, 61.9.1 miles and 1 degree of latitude.
Can I accept that? Yes, I can.
Okay,
can I agree with it?
All right, let's move on.
Because I've never done it myself.
Okay, so there's no really substantive.
Can I trust it? Sure, why not? For my everyday life, why not?
Yeah, so I could superimpose the circles that we did before over this map, and it would look the same.
Sure.
Okay, good. That's all I wanted to go over with you. All right, so let's go. So here we are. We're looking at all 3 of them. So now we're saying those are the circles. There's the A map. Pretty much all the same.
Mm-hmm.
All right, so let's get back to the 45 degrees. Okay. There's you have to forgive me. There's a little bit of maths going on over here, but I've tried to simplify it as much as I can. So here we've got 45 degrees at Minneapolis in the United States. people there looking up and they see it's 45 degrees. So they can say, well, 45 times 69.1, 3109 miles. So I did this at 1 o'clock in the morning, so I don't know, maybe if I've got something wrong, somebody correct that.
Looks good to me.
All right, so 3109.5 miles away from the North Pole, pretty much flat. 3,109.5 miles. Okay, all right. And because it's 45 degrees, then I'm pretty much then I also know that the other the opposite to the at Minneapolis, that would be also 3,109.5 miles, because we've got an equilateral, an isosceles triangle, okay, a right angle isosceles triangle. So if we've got 90 degrees and one angle is 45, the other must also be 45, okay?
Yeah.
And the two sides have to be equal as well. I think you'd agree with that.
Yes,
All right, good.
Triangles add up to 180.
Excellent. Yeah. Okay. Good. So now we've got
straight lines.
We now have a height, by the way, which is interesting. Okay. We'll keep going.
You have estimates, yes.
Yeah. So now we have 3,109.5 miles because the star didn't go down. It didn't suddenly decide to take a dive, and we're now at 30 degrees. Okay, so this is 30 degrees. If we predict the distance, so 30 opposite to that will be 60. So 60 times 69.1, so 4,146 miles now. Okay, as we're getting closer to the equator, it's getting further away. Obviously, it's still flat. Okay, so we're still talking about flat. Okay, all right. So let's predict. So in this here, I'm saying let's predict the distance at 30. Okay, all right, using the angle of Polaris. Okay, so we can predict that it's going to be 4,146 miles. Do you agree with that?
Sure.
Yeah, sure. Okay, good. All right. So prediction, our predicted distance was 4,146 miles. We've got a problem though. You see, the tan, if you multiply 3,190.5 by the tan of 60, which, because you obviously know trigonometry, I presume, we get 5,385.8 miles. We don't get 4,146 miles. So this relationship between 69.1 miles and the angle doesn't work anymore. It's broken down. It's obviously something wrong.
Broken down?
Well, what did we predict? We predicted 4,146 miles.
Okay, so what's broken down? Again, what's broken down?
What's broken down is it's not true. When we actually get to that position, it's on flat Earth. It's not true. It's not 4,146 miles as we predicted. It should be. Turns out to be 5,385.8 miles.
Okay.
Because on flat Earth, the relationship between 69.1 mile and the angle of elevation to Polaris doesn't match. That relationship's not true. That it's not 69.1 miles per degree anymore.
Okay. Who fucked up their measurements?
You can see this is not true then. So anybody who says that who looks up any flat earther who's basically anywhere looking up at Polaris can't rely on the 69.1 miles per degree. Okay. They can't rely on that. And yet it's part of celestial navigation, isn't it?
Sure.
Okay, I just want you to acknowledge this, all right? I told you before, I never get you to change your mind, but I want you to see that it's wrong, right? So in other words, people like Oakley and those people who are saying that
Look, okay, I'm going to stop you there again. Sorry again to interrupt.
Yeah.
But no, not enough name dropping. I don't care, really, about Oakley.
No, but I do.
Attach me to all these groups.
That's okay. I do.
Me and look, let me go here for a second, Bill. Sorry. Look, I don't care. This is between me. I speak for myself and myself alone.
That's okay. I'm not accusing you of repeating what he says. I'm just telling you what he says. That's all. All right. I'm not accusing you of repeating it. Okay.
I don't care. And you're telling me this because you think I've been brainwashed by these people.
No, not at all.
And conned me. Yes, you do. Don't even try to say you don't.
No, I'm not implying that here. Okay. Yes, I'm definitely not implying that here. I'm just letting you know. I'm just telling you now, the flat Earth that of the people in the flat Earth community, and he's probably one of the leaders, would say that, in fact, often say that the angle that the angle of elevation to Polaris tells them on flat Earth how far away they are from the GP. It tells them that. They say that often. I'm not saying that you say that, because you can see now, because you're a rational person, you can see that's not true. So anytime you hear one of them say, if you look up at Polaris and get your angle of elevation, you cannot rely on 69.1 miles per degree of latitude. In other words, that's meaningless to you. That latitude, that latitude compared to the angle of elevation to Polaris is meaningless to you on flat Earth. This is what I'm saying. You now realize that. Okay? But the rest of the flat Earth community are still saying stuff like that, especially, and I will say his name because I'm not scared to use it, especially people like Oakley will say that. We know, and you know now, that it's false. So to say that the Earth is measured flat because when you look up at Polaris, you can determine how far away you are from the North Pole, the GP of Polaris, as 69.1 miles, and hence matching your latitude, is patently wrong. It could not happen on flat Earth. So that won't be something you would repeat again, would you? If you ever did.
Nope.
Great. We're on the right track. So this is just at north, right? So let's carry on. Now, if we now go all the way to 90 south, okay? And we're thinking, well, should I be able to see Polaris from 90 degrees south? That's all of 180 degrees between the North Pole and should I be able to see Polaris? Well, that's something we can easily work out, because trigonometry is a thing. That's often spoken about by people in the flat Earth community because they love trigonometry. I don't know how many of them actually know how to do it, but that's another thing. But certainly they haven't thought about it, because if they had thought about it, this would immediately come to their attention. That 180 degrees times 69.1, assuming that I haven't mucked up the math here, anybody can check that out. Let me know. It's 12,438 miles. That's 180 times 69.1. That's how far away from the GP of the North Pole, from the North Pole, which is Polaris, is it, to 90 south. So now that we know the 3,100, it's covered by, what was it? The 3,109.5. We've got that worked out. So we're now going to try and see if we can work out what is the angle we'd be looking up at. What would be our angle of elevation to see Polaris? What would we need? What would that be angle of elevation be to see Polaris? Okay, well, it's right there. The arctan of 3,109.5 over the 12,400, that's the opposite over the adjacent, will give us the degrees. So you should be able to get your inclinometer or your sextant on flat Earth. 14.0362 degrees, and you will see Polaris. Technically, you will not. Because this is the prediction. On flat Earth, you could see Polaris from 90 degrees south. Why not? Earth cannot be measured flat. I'll repeat that. Earth cannot, it could not be measured flat. Anybody who says Earth is measured flat has lied to you, Richard. I've proved it.
No, you have.
Hopefully someone says that to you again, you tell them you're wrong. Earth has not been measured
I will
flat.
tell them they're wrong. I'll tell them that the Earth can't be measured accurately. That's what I'll tell them.
It has not been measured flat. They keep saying Earth is measured flat. That's patently false. Remember to tell them that, Richard, the next time you're in a chat with one of them and they say that. The next time you're in Globebusters,
I've never heard it until
the next time you're in Globebusters, you'll hear them say that. I've seen you in Globebusters. The next time you're there.
Whoa. Stop. When? And prove that. Because I have not watched those guys. Maybe when they first came out, I might have checked them out a few episodes, but no. See, that's what I mean. You guys assume all this shit. You don't even know who started me in this. The person that I watched most and listened to most and got most of my information from, you've never even heard of, and you never will.
You want to share?
Passed away for a few years now. A Plain Truth was the name.
All right. So now you know. Let's just get down to the syntax. Now you know Earth could not be measured flat. So therefore, the statement that Earth is measured flat is patently a lie. That's not true.
According to you.
No. According to the evidence, Richard.
According to your calculations.
The evidence, Richard. The evidence, Richard. I've been through it with you. Yes, the maths works, Richard.
Okay. Define math for me, Phil. I've asked this question so much and I've never got a correct answer. Define math for me. Simple and clear. Define math. Remember what we agreed on in the beginning, that we have to find, some common ground, equal to stand on? Define math, please.
Richard, I said to you at the beginning, you don't have the scaffolding for me to go down any of those rabbit holes, all right? We're just going to stay with common sense. I gave this to you. Here is the evidence in front of you, Richard, okay? So you do with it.
Phil?
Richard, you do with it what you like. Okay.
Oh my
I
God.
gave it to you.
Again, define math. Can you not even simply define math? You're talking to a 5-year-old right now, Phil. He asks you what math is. What would you say?
It's over your head.
I'm not going to. Please, everybody, nobody just argue with him about that. Richard, it's a tool by which we can define what's around us. Okay.
I'll agree it's a tool.
Yeah.
You know what I would tell them? It's a descriptive language, period.
Richard, the point is, the math tells us that you must be able to see Polaris from 90 degrees south, and you can't. You can barely see Polaris unless you are high up from zero.
Perspective says you
from the equator.
The way your eyes see says you can't.
Richard, because you're a rational person, Richard, this must come into your consciousness.
Why does this trigger you guys so much? I mean, now you're raising your voice at me and calling me irrational.
No, I didn't say you were irrational. I said you are rational.
I thought you said, sorry, I thought you said you're...
No, I didn't say you're irrational. I've never said that. I made a point of saying you're a rational person because you are a rational person, Richard. You've got to look at this. You've got now ask yourself the hard questions. Why can't you see Polaris from 90 degrees? Why can't you see Polaris? Why can you barely see it?
I have plenty of ideas why. Again, perspective won't allow you to see that because it's dropping as you move away from it, like everything does when it's above you. I see a plane also go below the horizon, as you guys like to call it. Is it actually going below the horizon?
You can see from the math that you must be able. You must be able. Is the
plane going below the horizon?
No.
No.
Well, exactly. Of course, you don't see the plane going. You go up to the horizon.
Yes, I do see the plane go below the horizon.
Okay, good. And then, what's your point?
I know it isn't going below the horizon physically in nature because that would be, I would have to call the cops because there's been a plane crash. No, and I've been on a number of planes.
No, it does.
They fly in straight lines, Phil. But
no, Richard,
to me, on the plane would go. Look, stop interrupting, please. You've had more. I've been patient and listening to you. Pretty good.
Okay, go on.
Perspective. I see that plane. It comes up from one horizon. It goes below the other horizon, 180 degrees. Right or wrong?
Okay.
Right or wrong? It's a simple question. Just give me a right or wrong.
Well, when you see it, after what happens after the horizon? After the plane reaches the, as you say, reaches the horizon, what happens after that?
It's still traveling at the same altitude in a straight line. I just can't see it anymore.
Why can't you see it anymore?
Because I can't see forever.
Why couldn't you get a telescope?
See forever. Do you know how eyesight works?
Why couldn't you get a telescope and see it?
Do you know how eyesight works?
Yes, Richard. I'm not going down that eyesight rabbit hole. Okay, I'm a physicist, not a biologist.
Eyesight rabbit hole. Come on. Okay, go ahead.
So, where does the plane go then?
It can again, right or wrong, simple, yes or no, Phil. The plane continues on its straight line path. When it reaches the horizon,
when it reaches the horizon, you grab a telescope. Why can you still not see it?
There is a limit to what you can see. Even telescopes.
I'm talking about the telescope. I'm talking about it. Once it reaches, you can see it's reached the horizon and then just disappears. You grab a telescope, you still can't see it. Why not?
Because of the way optics works.
How come you can see the star that's in the same direction at the horizon?
Oh my god.
Why can you see the star? You can't see the plane.
Can I see the star if I move far enough away from it, like that plane, or will it do exactly what that plane's doing? Drop, continually
doesn't it?
drop until it goes
You
beyond my sight and it gets to the horizon and then it disappears. It disappears
Actually-
into the horizon. The horizon
Actually-
is fucking optical. It is not a physical thing.
Richard, I'm just pointing out these things, okay? You can take it or leave it. All right, I'm happy with that, okay? All right.
You can.
Okay, so
that's
let's carry on.
Like overcomplicating everything. It's like
Let's
it's
carry on.
simple perspective.
Now that we know, at least in your mind, now that you've seen the concentric circles, you've learned a couple of things. One is that 69.1 miles per degree of latitude doesn't work on flat Earth. Okay, so we've gone past
It
that.
doesn't work
Other
on
thing is
your idea of flat Earth.
and plus, you also know that those concentric circles pretty much match what that AE map looks like. So we've got that far. Okay. All right. I'm going to stop sharing this. So just bear with me for a minute. I've got some other things to help so that we can discuss. Okay. Here we go. All right.
You want to talk about Oakley and what he says and what I believe? Read the chat, Bill. Look at these people. Do you believe what they're saying?
Okay.
Claiming stars are closer than planes.
Going to share this with you. Okay. You see that?
Yeah.
What do you think that is?
It's like a picture of the stars, time-lapse.
Yeah. So how is it like that? How did it turn out to be like that? How did this person who made this picture?
Designed.
Those are individual stars,
they
aren't they?
pointed the camera and took a bunch of pictures.
Yeah. So they point the camera, left the time delay in the camera, so this is what effectively creates these star trails. Yeah. So we can see that the stars are effectively going around in a circle, right?
Yep.
Okay.
Circling Polaris.
But we see that when we look south, because that's what this is, by the way.
Are they all not circling Polaris?
That's a good question, Richard. Are they all not circling Polaris? Okay, so if they're all circling Polaris, okay, remember, I've said that I've agreed that you're a rational person, okay?
Yeah, agreed. They're all circling Polaris.
So Richard, before I show you what's coming up next, okay, I want you to think about this. So if where I am, I'm in the south, 37 degrees. I would have to look north. If it was flat Earth, I would be able to see Polaris, by the way. Okay. All right. So if I'm looking at Polaris and these things are effectively the stars, the furthest stars are going around my head, aren't they? Like if I turn around, I see the star over there. I can follow the star around, follow the star around, follow the star around.
You have to physically move and follow the star, yes.
Yeah, so I could do that, right? Yeah.
Yeah, because the stars are in motion.
I could follow that. Yes, because they all of them are going around the North Pole, right?
Sure. From everything I've observed, yeah.
All right. Okay. Hang on to that
Sure,
thought.
it's well established that everything circles the North Pole, or
Hang on.
Polaris.
Hang on. Hang on to that thought. I'm going to stop sharing that as you've seen it, and I'm going to share something else. Okay. Where is it? Do that properly. Excuse me for a second. Did not do that properly. Let's try again. That's it.
What do you, you're just looking for the
horizontal one, yeah.
Just the thing you're trying to share. Okay.
Yeah. It's okay.
Yeah.
I think I've got it. It's all right. I've got it now.
You don't have to stop sharing and reshare. You can go to the new tab and then say, usually depending on the browser, you say share this tab. So
Yeah. Thank you.
yeah.
You live and you learn. Okay. So let me share this with you, please. All right.
I agree. You live and you learn.
Some people learn, some don't.
Well, I can agree there too.
Yeah, we know who's not wanting to learn tonight, but maybe we're holding out hope for you, Dick. All right, I'll step
Bill's
back.
not wanting to learn.
So Richard, you saw the ones before. They were circles, all right, and so we're looking at the southern horizon, and we're seeing these circular stars, right? They're going around your head. Richard, can you explain to me how a rational person would think that's possible and not this? In other words, if something's going around your head and some of them are close to the horizon, why would they not look like this instead of circles?
I don't understand.
Come on, Richard. If there's an aeroplane going around your head, let's bring it close. If there's an aeroplane that's circling, you know, sometimes you see the police helicopters circling, and you look at them, they pass by you horizontally, don't they?
No.
You see them horizontally going around. The further away, they get closer to the horizon, but they're still horizontal, right? When they go from left to right or right to left, they're horizontal.
Yeah,
They don't make circles. They don't make circles in the sky in front of you, do they?
They have their natural upright orientation. Yeah, the whole time.
If the stars are going around your head, why are they not?
The whole Earth.
Yeah, why are they not horizontal when you're looking at them? You're facing south. You're looking at stars that are in the south. Why are they going around? Why, for instance, does the Southern Cross turn upside down during the night? Why doesn't it just go across your field of vision like this, like what you're looking at on the screen?
Again, I really don't understand what you're.
You don't understand what I'm trying. You don't understand what I'm trying to get at?
No, I really don't. To me, it's optics. It's an optical illusion.
Let's just go slowly, Richard.
It's optics. It's all optics.
Richard?
Because we don't know what the stars are. We don't know how they move.
Richard?
We just know they do. And they do follow very specific patterns.
That's the line that we hear from the flat earthers, all right? You're much more rational than that.
That's the line you hear from people who observe the sky. It's not flat earthers. Enough with that, please. Again, Richard? You're talking to me.
Yes, Richard, you're the rational one. Can you please, if you're looking at an aeroplane, that's going
I'm looking
left
at
to
the
right.
stars, Phil. I'm not looking at an airplane.
Are the stars not doing what the airplane does?
No, they're not.
What are they doing? What's different? If they're all going around Polaris,
They're not the airplanes, Phil.
Richard,
I don't know. Did you have a hand in their creation? Then how can you ever know how they do what they do? They
Richard,
seem to circle above and around the Earth.
Richard, if they're going around a single point at Polaris, and then and some of them are on the far south near the horizon, why are they not going horizontally? Why do they go around in a circle?
I don't know. Phil.
And we're still remember how we agreed about those four people, right? Those people in those different places. Let's say at Capricorn. Remember that the circle we did,
Yes.
Tropics of Capricorn. Yeah, you remember that. Okay. Do you know that all those people will stand and look south and see the same circle?
Are they looking in the same direction?
No, they're all looking in completely different directions.
Okay, still.
But they still see the same thing. So at least two of them will see the same thing at the same time.
Yes, we all see the sun, moon, and stars circle above and around the Earth.
Richard, try to focus,
Where
please.
is the problem? Do you disagree?
The problem, Richard, is they shouldn't be seeing, first of all, if they're looking at different directions, they should not see the same thing.
Why not?
How can they look in different directions and see the same thing? Let's go back to our situation, all right? Okay.
They see stars doing the same thing. Again, circling above and around the Earth. What is so hard to understand? Are you denying that initial observation? And how do you know everything's circling above and around the Earth? Because you're on the stationary object that you're taking the observation from.
Richard, focus, okay? What would the airplane do if the airplane is moving?
Condescending as well.
What would the airplane do if it was traveling from east to west, from your left to right, in the distance? So it's going around you. What would it be? Would it be going around in circles like a loop-to-loop, or would it be going horizontally across your field of view? That's not a hard question, Richard.
I would imagine horizontally.
Why is that different to how the stars would do? They're also going around your head.
Is an airplane a star, Dr. Phil?
Doesn't matter. It's just another object.
Stuck with one TV channel and watch the
It's just another object, Richard. Just another object.
It's just another object, okay.
That's supposedly going around you, and yet it doesn't go around you, does it? Does loop-to-loops. If I look at the Southern Cross doesn't just go left to right, does it? It just turns upside down.
Again, it rotates, okay.
Why does it rotate instead of going horizontally across your field of view? If all of it is going around the central point, the North Pole, if all of it's going around,
acknowledging that the stars are in motion?
No, I'm not. That's beside the point.
Okay, then what are we talking about?
The Earth moves. Okay, the Earth spins.
No, it doesn't. But
all right. Okay, we're not going there. No. I'm not getting away from this until we can work it out, because it's not a very difficult thing to understand that the stars should be going horizontally.
Why?
If they're all going around the same point.
Why?
What do you mean why?
Why?
This is not hard, Richard. Come on.
It's just an application of geometry, that's all.
assuming you
simple
know
stuff.
what the stars are and how they do what they do.
Oh, it
You
doesn't
guys
matter what they
don't.
are. Yeah, you don't need to know what something's made of
It
to know
doesn't
where it
matter
is.
what they are or how they do what they do.
No, not at all. No.
Not
Richard,
at all. Okay.
Richard, when we see the aeroplane, when we see an object in the sky and it's too far away, we see something there, but we can't tell whether it's a 737 or a 747 or a helicopter for that matter. Okay,
You can't
but
tell
it's
the
still going
difference between
around
an
us.
airplane and a
It's still
helicopter.
going around us.
You've got more issues.
Well, if it's
It's
at
still
night,
going
if
around
it's
us,
at
though,
night
isn't
and all
it?
you see is the lights from it, you don't know what it is.
Well, I know a helicopter when I hear it.
Okay, it looks like you're going to try to not answer this, aren't you?
He knows he's trapped.
I said I don't know why they don't appear to do what you assume they should appear to do.
Not only that, Richard, do you know what else you don't know? Why 4 people looking in totally different directions also see the same thing.
Do they see the same? Are they looking at the same star? The exact same
Yes.
star? Are they all following the exact same star?
2 of them at least can see the exact same star at the same time.
So
Because,
no,
you know, the others,
they're not
it'll be
all looking
daylight.
at the exact same point. Okay.
Yes, yes.
What don't I understand then?
Then there's 2 people in different directions are looking at the same thing, and they see the Southern Cross turn
So they're
upside
looking
down
at the
during the
same
night.
star. They're looking at the exact same star. They are all tracking the exact same star.
Yes,
Are they?
at the same time, Richard.
I don't believe that. The
Right,
exact
it's
same
true.
star, the exact same time. They're all looking in opposite directions, and they all do a 360.
They're all looking at different directions. Let me get my I will unshare this, but because I'm going to go back to my PowerPoint presentation. It's important. Okay. So let's go to the southern ones. Okay. This one here is probably useful because this is at Capricorn. Okay. So if you're standing at Capricorn, you're standing at any of these places, let's say here in South Africa or here in Australia at Alice Springs.
We don't see it at the moment.
Oh, sorry, I thought I was sharing. It's okay. Let me do that now. Okay.
Ryan just started making an appearance for me.
Okay. It's okay. Sorry. I beg your
I
pardon.
see the Big Dipper every year, every day, every night. Close to Polaris, too.
That is what the globe predicts. Yep.
That is what the observations show us, yes. We see the Big Dipper not change its shape in any way whatsoever in over 30 years of watching. All circle Polaris. The stars are physically in rotation.
It has changed in 30 years.
No, it hasn't.
Richard. Okay. Richard, we're having a little bit of a problem, getting past this. So let's try
Of course
it.
we are.
Let's have a look at this.
Because
Okay.
we're arguing observations. And
So Richard,
they're
let's have another look
subjective.
at this. Concentrate. Have a look at this.
Hmm.
You can see what's on the screen now. That's Tropic of Capricorn. Okay. So you can see the people in South Africa, the people in Alice Springs. Okay. All right. So those people in South Africa and people in Alice Springs at the same exact time. Okay. At exactly the same time can look south. In other words, south is opposite. You see the arrow that's pointing inwards from
Yes, south is opposite of
Polokwane,
north.
South Africa? Imagine that arrow is the other direction, heading south. The people in Alice Springs, imagine their arrow is in the other direction, heading south. But they see the same stars. They see the Southern Cross turn upside down during the night, Richard.
Okay.
I know that surprised you that it was the same stars.
Actually, it's not. Again, now you're but you won't. Are the stars in motion? Yes or no?
It doesn't matter. It looks like they're in
Doesn't
motion to
matter.
you. It looks like they're
It
in
sure
motion to you.
does. Okay, thank you.
Yeah.
To you, but not to you.
And they go around in circles, Richard. In other words, the Southern Cross doesn't go left to right or right to left horizontally as it should, as it's predicted on flat Earth. It goes around
Nice
in
straw
circles,
man.
Richard.
Nice straw man.
No, I went through all of this so that we wouldn't have a straw man to burn down.
Yeah, you keep saying this is impossible on a flat Earth. This observation is impossible on a flat Earth. These mathematics are impossible on a flat
I'm
Earth.
happy for you to explain how someone looking at totally different directions, say in this case 90 degrees away from each other, looking in 90 degrees directions away from each other, get to see the same stars at exactly the same time.
I don't know.
That's what I wanted to hear, Richard.
I can't, and I don't
Richard,
even, you know what?
Richard,
I can't even say that I know it happens because I've never seen it myself, and I can't see it myself.
Richard, that's the honest question. That's the honest answer. You don't know.
Yep.
Of course you don't. Richard, because it's not
But
possible.
you do, right?
It's not possible, Richard.
According to you.
If the Earth is flat, it's impossible. But if it's a globe, 100% perfectly explained.
And that's the only explanation, huh?
Now, Richard, I've got more for you. Richard, think about this. Using these things, okay? This is...
Again,
can you tell me, now that you know,
observation.
Richard,
do you know the difference between subjective and objective?
Richard, now that you know,
no,
you've got in your mind's eye, because I remember when I asked you in your mind's eye, what does it look like, flat Earth? Now you have a much clearer picture because now you know about the concentric circles, don't you? We've done that. We know about the sun
Phil,
between.
I can draw concentric circles on top of a table around the center point. Good. All right. I'm talking about the Earth. I don't care about what goes on beyond the Earth because it's not for me to understand. And you don't know what's going on beyond the Earth either because you have never been there. And you never will be there.
Richard, there they are, those circles that we worked on.
Yes.
You notice, Richard, that they get between between longitudes. I think probably better to look at this. Better to look at the this one. Between longitudes, you can see that the length of the latitudes get wider and wider.
Worse.
Of course, yeah, exactly. Of course, of course.
Yeah.
Well, Richard, I've got news for you. You see,
yeah, they're all curved.
You see, south of the equator, the latitudes get closer and closer. The longitudes get closer and closer together. The latitudes get shorter and shorter. And you know how we know this, Richard?
How do you know this, Phil?
Yeah. It's because GPS works.
Ground positioning system works. Awesome.
You can call it what you like.
Yeah, exactly.
By the way, I have a little homework. I have a little homework for you, Richard, if you don't mind, because I know that how keen you are on knowing the truth. There's a pretty large company called Garmin. They make these GPS receivers. They manufacture them. Lots of people manufacture GPS, but they are huge. Okay, they're called Garmin.
My first one was a Garmin.
Exactly. So this
No.
this Garmin, what do you suppose they would say if you were to call one of their engineers and say, where do the signals for GPS come from? What do you suppose they would say?
I don't know. Towers?
You think they would say towers? You think
Probably.
the engineers?
Maybe they'll say satellites.
I am pretty sure I know what they'll say, but you think, are you confident they'll say towers?
I don't speak for other people, so I don't know what they'll say.
That was
I
the
know what
homework.
I would say. Again,
Yeah, but
ground
why don't you?
position.
But they the people who make them. They the people who make them. So they would know where the signals come from, wouldn't they?
Not necessarily, but
You don't think the people who make it don't know where the signals come from?
Where will they tell me the signals are coming from?
Of course, they're going to say satellites, Richard, because it takes 4 of those satellites each time to get a fix.
So no ground towers are used in navigation whatsoever.
Not to get a fix on one of those Garmin receivers. No. You see those people see those people who went to Antarctica. They showed us while they were there. Actually, the guy who's standing right there, who's right here with us, he actually had it in his hand and showed us.
Okay.
He showed us his GPS position.
So what?
Where were the 4 towers, Richard?
I wouldn't doubt they have towers on the island known as Antarctica, but whatever. You'll never see them. But regardless, so what? I'll give you the satellites. I don't care. Are you telling me I got no problem thinking something can orbit something else? Like, what's the problem? You guys seem to think, the only way satellites are possible is if it's a ball.
It is. That's the only way it's possible. Yeah.
Why? So nothing can orbit a stationary plane?
Correct.
All right. Now we're getting a little bit off the track. So Richard, the thing about it is that
we're way off track if you don't acknowledge, if you can't even be intellectually honest enough to acknowledge that something can't orbit a stationary plane.
That doesn't make any sense at all.
Richard, you're in no position to talk about being intellectually honest when you know that the stars should be going horizontally across your field of view.
I don't know this.
And you know, because they're going around the North Pole, Richard, so you know that they must be going horizontally across your field of view when you look south, okay? That's being intellectually honest, okay?
No, being intellectually honest is saying I don't know how they do what they do.
Richard, it doesn't matter what you say. I want other people to hear you say it. Okay? That's the point. I want them, other people who are thinking about this and say, wow, of course they have to go horizontally. Of course they do. And, Richard, what I was alluding to is that the distance along the equator between 2 longitudes is greater than the distance along any other 2 latitudes, both north and south of the equator.
Measure them all.
You need to come up. You with me, we worked on it together, put those circles together. You see how it doesn't work, Richard?
It doesn't work.
You see that that's not right?
I can't draw concentric circles around a center point on the top of a table.
You did, and you notice that the distance, as you're looking at it right now, it's in front of you, Richard. You can see that as you go further south, the distance along latitudes between two longitudes is getting wider and wider. But that's not what happens in reality, Richard.
Because lines diverge from a single point. Like what? Oh my God. you
Well,
guys.
it's not what happens in reality, Richard. That doesn't match this thing that's in front of you. And this is the thing we agreed on.
It doesn't match this thing? How?
Okay. We're not going to, it's all right, Richard. I just wanted you to say it and I wanted you people to hear you. All right. Okay. Okay. I know we're not going to agree on stuff. Let's move to a different topic. Okay.
You can't agree on anything with a flat earther because
Okay,
you
Richard.
hate the idea so much.
Okay, Richard.
I know.
So, Richard, Richard, it's a wonderful thing that those guys did going to Antarctica. Okay. Oh, by the way, before I get onto that, I do have to show you one last thing, okay, about star trails. All right.
Star trail, not Earth trails.
So I'm going to show you this. You're going to love this, Richard. You're going to absolutely love it. Look at this, Richard. I actually wrote to the guy who produced this. His name is Stefan. Okay. Now, this is at the equator. This was taken at the equator. What's happening to the stars? You see, they are going below the horizon. Richard, if this was flat Earth with all the stars going around over your head, those stars near the horizon,
those stars aren't going over my head from what I'm looking at. They're going in front of me.
Pay attention, Richard. They would be going horizontally, Richard. They'd be going horizontally. Richard, according to anybody with common sense, that's what we were appealing to, your common sense. Remember, your staggering edifice of common sense that matches your confidence.
Condescending. You are the people that think you have this special knowledge and you're smarter than everyone else.
Richard.
I don't pretend to think this.
No, Richard, I'm not taking any credit. Where I've come academically is irrelevant to this. A fifth grader would be able to tell you what the stars should be doing. It's just common sense.
Is it?
And you have piles of it. Come on.
No, well, I'm not a fifth grader. I actually think, well, first, I don't know what the stars are. I don't know what's beyond.
You don't need to, Richard. You don't need to. You know that if they're going around your head, they should be going horizontally across your field of view. You know that.
Oh my God, no, I don't.
Look at them, Richard. They're going down below the horizon.
I don't know which alloy of aluminum airplanes are made out of, but I still can see where an airplane is.
And look, they're going below the horizon.
Yeah, and an airplane's a physical object we know and touch and test and.
Richard, how can they be going?
The stars aren't.
Richard, how can they be going below the horizon at the equator?
I don't know. It's the way your eyes see the world, obviously. Because I know for a fact they're not going below the horizon.
Richard, do you really think people are going to buy that?
I don't care what people buy or not.
Weak sauce.
I'm not. Weak sauce?
Weak sauce.
Why, you care about what other people think? I don't.
Really, Richard? Do you want to leave it like that? Richard, do you really want to leave it like that you don't understand that these stars should be going horizontally and yet they're going below the horizon? Where are they going off to, Richard, if they're going below the horizon?
Underneath.
Where could they possibly be going? They're going underneath the flat Earth now.
Possibly. I don't know how big the Earth is. I don't know what's beyond the Earth.
We're obviously looking at the edge of it, aren't we, Richard?
Are you looking at the edge of it?
We must be, Richard, if they're going beneath it.
Oh my God.
You're a
I'm
rational
looking
person,
at the
Richard.
horizon. Is the horizon apparent or physical?
Richard,
Have you ever reached the horizon, Phil?
if they're going below the horizon, if they're going, you can see them.
If I
Going below
walk
them.
forward towards those stars, would they still? Of course. Would they continuously go below the horizon?
Yes. Yes, Richard, they would.
Yes, they would.
Of course.
Of course. This is the way we see them.
Why aren't they going left to right or right to left horizontally, Richard? You need to answer that
I
question.
don't know. Why do I need to answer
Okay,
that for you?
fair enough. All right. Okay.
Why do I need to answer that for you?
All right. I got your answer. That's okay. You don't know, it's fine. And you don't know is a valid answer. Okay. It's a respectable answer, actually.
Absolutely. That's why you guys are so afraid to say it. You can never say, I don't know. I don't know. That's beyond the physical limits of my abilities to know.
Well, but the thing is, we do know those things. I'll say I don't know the things I don't know.
We. Who is we? Sounds conspiratorial to me.
Most people, Richard, most people.
Yeah, it's a royal we.
Most people.
It's people that have studied and looked at it and examined it and worked on it. Yeah.
Looked at it. They haven't studied. There's no physicality to the stars.
Richard, we're going on another topic here. Richard, have a look at the screen.
Going on another topic.
What's happening here? From the vantage of a balloon. Now, I just need to ask you some questions just to see where your level is actually at physics. I asked some kids a few days ago in preparation to see what a kid would say. I said, "Why is the sky blue, Richard?"
The way it is.
No one ever explained it to you?
No, you never did. And
No, not me. I'm talking about in your life. I mean,
you've never told me what the black stuff above the blue stuff is.
Are you someone in your 40s or 50s or something like that?
40s?
In all those 40 years, no one's ever said to you why the sky's blue?
Yes, they have.
Well, why then? Why? You tell me what did they tell you, Richard? What did they tell you?
It's the way the light from the sun interacts with the atmosphere.
Mm-hmm. Good, pretty good. You're on the right track.
Yeah, pretty good. It's actually
so you do know. You could have answered that question earlier, right? Just like that.
No, I won't say I know that for sure.
Yes, you do, Richard. Okay, remember that intellectually honest thing. All right, you do know it. You're pretty accurate. It's the way the light interacts with the molecules of air. Okay.
With the
so Richard, just bear with me because you may not know this, and it's okay if you don't. All right, and that is that as the air gets thinner and thinner, so does that level of blue. So the more blue it is, the thicker the air. That makes sense because it's blue because the light's being scattered. Right, the blue wavelengths of light are scattered, so that's why it looks blue, right? And obviously that gets more and more blue, more and more concentrated as we get closer to the Earth. That's because there is a gradient. Right? There's a pressure gradient. If you want to test to see if there's a pressure gradient, you, Richard, can do that yourself with your own.
I know there's a pressure gradient.
Okay, good. So Richard, you can see that from this photo. Isn't it wonderful though? You're seeing the moon up there. From this photo, you can see that it gradually gets less and less and less to a point where it's just black.
Sure.
Now that you know, Richard, why it's blue, why is it black?
Again, I don't know. It's a different medium. It's beyond my ability to go there and figure out what the medium is, but it's a different medium.
I said to you, I didn't expect you to answer that question, but because you did answer the question about white, blue. Now imagine that that because this pressure gradient gets so low, fewer and fewer particles. Okay, fewer and fewer particles.
Does it ever reach zero?
So low that there's not enough of those particles to scatter light in a way that you'd be able to see them.
Sure.
Because what's black? It's black because it's not, you can't see it, right?
What is it? The black
There's
is
no light,
the
no
absence of
light.
color, white
It's
is
an
the
absence of
color.
light. Absence of light is right. See? You're actually quite intelligent, Richard.
I like to
Okay,
think
so
I've got
okay.
logic.
There's obviously something wrong with your intellectual honesty, but that's not to do with your intelligence, though.
Buddy,
Okay.
give me a break. There's nothing wrong with my intellectual honesty. I have no problem
Well,
admitting
you tell me that you agree that the stars should be going horizontally. I'll withdraw that. Okay. Now, so Richard, you can see now that you've got this black area. That's because there's a pressure gradient. It gets so low. There's so little of it. There's so few molecules between where that blue area ends and, let's say, the moon and beyond the moon. Okay, that it's black because of the pressure gradient. Now, Richard,
I disagree.
this is what I hear from the flat Earth community all the time. They say, how can you have they say outright
Pressure next to a vacuum.
yeah, they say space is fake. Do you say space is fake, Richard?
Nope. But
You agree?
I want to know, again, what is your definition of space?
I need that from you.
My definition of space? Nothing.
Yeah.
Nothing.
So are we looking at space then?
You're not looking at nothing, no.
No, we're not looking at nothing, but space doesn't have nothing. No one says that it has nothing.
I define space as nothing, as simply as I can.
That's not what space. That's not what it means.
What's in between me and you right now, Phil? Space.
Yeah, I'm talking. Well, there's not nothing in between you and me either. Okay.
You know what I mean? Hypothetically, hyperbole, whatever you want to call it.
Yeah. All right. Okay. So that's okay, Richard. We can. That's a different topic again. But so you can see, Richard. You can see, Richard, that I'm telling you what most people will tell you. All right. Okay. And that is that black area is black because there are very, very few particles of air. Okay. Any particles of air, hydrogen, nitrogen, oxygen, all that, okay, in that area. And that's a very vast area, isn't it, Richard? Because if you have a look at that, you see that blue area, Richard? That's only about 30 to 35 kilometers, that blue area. That's it. So you can see above it, there's a lot more, isn't there? In fact, just to the moon, you can see a huge amount of space. Mind you, the moon isn't right above the Earth. The moon is way up there. All right? Yeah, there is a whole bunch of nothing.
Different colors. I mean,
there is a whole bunch of nothing here, right? But Richard,
yep.
Why isn't
so? What's your definition of space? I gave you mine. What's yours?
Well, it's similar to yours. A place where there's a space where there's practically no molecules of air. Right, very, very, very few. Okay. So, Richard, my question is this, looking at this now. Why are the particles of air in that blue area not rushing to fill all that black area?
Because they're contained.
They contained by what?
I don't know. Something
Can you see?
physical.
Can you see it? Richard, we're looking at an actual photo. Do you see a container?
I see a line.
You think that's the container?
Line where they're separated. So
No, there's no distinct line, Richard. In fact, if you zoom in on this, you'll see
line.
that. No, there's no distinct line.
Wow. Okay.
There's no distinct line, Richard. It just gets less and less blue. Okay, it's very, very blurry at the edges and then gets less and less blue. This is an actual photo. This isn't made up, Richard. Richard, this is an actual photo.
Yes, I know. I agree. It's a straight, flat horizon. If you were to do a 360, it would be straight, flat all the way around you.
Richard, that looks straight to you? Seriously? That looks flat to you? Really?
It does. It looks straight. It doesn't.
Can't criticize. You've got bad eyesight, mate, and I have bad eyesight. I can see that's curved. I can see that's curved. Now, that's beside the point. So,
I don't see a curve.
Oh, you do, Richard. Remember that intellectual honesty thing? Yes,
I do. You're telling me what I see now?
Yes, Richard, I am telling you what you see.
It's not subjective. It's objective.
Yeah.
Yeah, it's objective that I see a straight line. As far as my eyes can tell, anyway.
It doesn't. Richard, other people.
It's not a good look. I mean, seriously.
Have good eyes.
Other people will be looking at the same thing and saying and thinking about what you're saying, Richard. Now, Richard, what is the container that you're talking about that's stopping all of that blue stuff there, that air?
I don't know.
That black air.
What is the container, Phil? You know gas pressure requires a container, right? No?
Not this. This is atmospheric. This is the atmosphere. There's no container here.
What is the atmosphere made of?
It's made out of the air particles and lots of space.
You can't even say that. You can't even say gas.
Sure.
Gases.
Gases, yes. Yeah, various gases. Yeah. 80%.
78% nitrogen.
Mm-hmm. So?
26% oxygen.
Yes.
What is there? Argon in there?
Yes.
I'm not sure what the other main one is.
There's a few. There's carbon dioxide, there's water, and so on. Okay?
Yeah, the percentages of those.
Methane, and so on. All right. So Richard, where is the container that's stopping all of these gases down here from rushing to fill that vast, huge black area up there around the moon?
Oh, yeah, I guess you're looking at it because in order to have gas pressure in the first place, you need a container. So
clearly, that's wrong, Richard. You're looking at an example.
Demonstrate it's wrong.
Right in
Show
front
me
of
gas without a container. Pressurize that.
You're looking at it. In fact, there is. It's always a gradient, Richard. Maybe you misunderstood this point. Maybe you misunderstand the point.
As you can tell, yeah, sure.
That this gradient just simply continues getting less and less and less.
Eventually, it hits the point where it's contained, and what then?
What's container? Well, no, but yeah, this area here, Richard.
What container? Logic and common sense, Phil. You need to physically contain a gas if you want to pressurize it.
Richard, this area, let's say between the moon and that blue area, why hasn't the gas that's in this blue area not filled all of it?
Because it's contained, Phil.
I don't see a container there stopping it. What's stopping a gas molecule here? What's stopping a gas molecule over there moving up to the moon? What's stopping it?
The container.
What container? We're looking at it, Richard. Is this like your straight line? That container? Like the one you just said was a straight line?
Can you have gas pressure without a container?
Of course, Richard, you're looking at it.
No, I'm not. And using the object in question is not scientific, Professor.
Yes, it is. Yeah. There's nothing wrong with
Demonstrate
it.
it.
It's
Nothing wrong with it.
Demonstrate it on a
It's in-
smaller
it's in
scale.
fact-
Don't need
Can
to.
you not
It's in fact
understand
superbly
scale?
good evidence.
An observation is superbly good evidence.
Yes.
Yes.
You got it.
Where's the physics? Again, every test you do on Earth in nature at sea level shows the opposite of what you guys say is going
It
on.
doesn't, Richard. You've
What do you
been
mean
listening
it
to-
doesn't? Provide an
you've been-
example where
He's
You've been
listening.
listening to fools.
He's listening to Oakley.
Pressurized
He's just
nitrogen.
he's
No,
just
listen.
parroting Oakley.
Listen to me for a second,
That's just
guys.
Oakley.
Like, if you guys try and say that you guys have talked and talked and talked, I've been really good. But you don't even let me get 2 sentences in and you cut me off.
Go for it, Richard. Tell us how the gas. Tell us about this container.
I don't know anything about the container. But
you
what I
there's
do
the
know
container.
is gas requires all testing, all gas laws require a container.
No.
You can't have a volume of gas without containing it.
We have a volume of gas. You're looking at a volume of gas there, and no container. I don't see a container.
Oh, then you have bad eyesight because I do.
You see
the
the
container?
What?
Nature tells me that it is required in order to have gas pressure.
You said you see it.
You don't.
I don't see a
You
container,
also
but you
said
said
you
you
see a
do.
curve, and I don't.
I'll do a poll on to see who can see the container. Just a second.
Does gas have a shape?
Hold on, Dick. Let me. I'm gonna just a second. I need to
Liquids and
finish.
gas have shapes.
Hold on, Dick. I need to finish the previous poll. The previous poll was 4 options.
I know. I voted for the fourth one.
Well, the winner is I don't like Dick, and then
Of course.
second is I can't get enough Dick with 22%. 4% says I like Dick, and 3% say they love Dick. Okay, anyway, I'll create a new one.
You know what would be nice, MC2? They even showed you the respect of calling you your MC2.
Yeah.
You
What?
know what would be nice? Donate the super chats from this to some charity.
Oh,
I don't need proof. I don't need anything. Just give me your word that you will donate the super chats. to a
I do
charity.
send money to charity.
Well, good.
Good.
I think we all do at some level. But just for me, out of respect, maybe, because I think I've been really good tonight, just donate the super chats from tonight. Or ballpark figure it. and
Nah.
Take a chunk.
Not tonight.
Okay.
But thanks for the request.
Okay, so
Doesn't hurt to try.
all right, Richard. All right, Richard. You
And yes, I do see it.
you see a container. You see a container there, right? Mm-hmm.
At
Yep.
least 7% agree with me.
Where, Richard? Just so I can frame it. Where is this container again that you see?
In front of you, in the picture. You
Yeah,
see
where
the
in
blue
the
stuff
picture?
there? You see the blue stuff, Phil? That it's
Richard,
reached the
that's
limit of its It's reached the limit of its containment, and it can't go anymore.
I see the blue stuff, Richard, but the blue stuff is the air. Where's the container part?
You see the line the blue stuff makes before the black stuff? There.
There's no. That's actually if you just if you I don't know how I could do that. I don't know. Is that making a difference? Is that
No?
can you see? Did that
Still see the same thing.
did that yeah but you it can you see now that you can see a lot closer to it, can't you? Yeah.
Yeah, I can see a separation
can-
of
Yeah,
blues
no,
and
you
whites
can't.
and
So
blacks.
you can actually see the blue just getting less and less and less, right? That. So we're right up to it. We're looking for the container, Richard.
You're looking at it. You see where the blue stops and it turns to black? There you go.
Which part's the container, Richard?
You see where the blue turns to black, fades
I
into
don't see
black?
that.
There you go. You don't see where blue fades into
So
black?
Richard,
Yeah, exactly. You can't
Richard-
even admit to that.
Okay, all right.
Good
okay,
job,
Richard.
Professor.
Yeah, no, listen. Okay, Richard. What's that ball up there?
I don't know. The moon?
It's the moon. It's outside of the container?
I don't know. Could
Well,
be.
Richard,
Could be
you
not.
said the container's all the way down here, Richard, and the moon is all the way up there. The moon must be outside of the container. And
Okay,
goodness
so
knows
it
how
is.
the hell are we looking through the container?
It's outside of the container.
And we're looking through the and Richard, are we above the container at this place with the balloon?
Obviously not.
So we're below so we're looking through it now, aren't we? At an angle.
Oh my God. What if you're at the top of it?
God's not going to save you on this one, mate.
Hey, God's not on your side here, bud.
Yeah, you guys hate God too, I know.
No. God's not on your side. He's
yeah, he is.
He's cringing right now. He's like, oh, stop.
Pressed under a seal.
Stop.
Wow,
You're
Richard,
embarrassing us.
So, Richard, the moon is above the container.
Created
Moon's
on
above the
day 4.
container, and we're looking at the moon through the container. Because we're not on top of it, the container, are we?
No, we're inside the container.
So we're looking through it, right? We're looking through it at the moon.
Okay.
Okay, good. I just wanted you to say it. That's all, Richard. Okay, I knew you would. Okay. Excellent. Oof, gosh. How long has it been?
Like that's what I'm talking about, though. You guys cannot demonstrate gas pressure without containment.
We
and
literally just
say,
did.
"Look, here's a
That's
picture of
amazing.
the Earth. Here's a picture. Yep, that's a physical demonstration.
Yes.
Now,
All
Richard,
right.
No, it's an observation.
Phil,
go on.
so we've got some questions from the audience. If you,
Yep, go ahead.
you guys are
sure.
Yeah, bring it on.
I am.
Bring on the whole group.
all right. Dick, have you seen the little animation that we got going for you? Some people didn't like it, but I think some people really liked it. I don't know.
I actually.
Now, Michael, can you just entertain? Could you please entertain Richard just for a minute?
Yeah,
I'm going to go into.
I gotcha. Kango44, question for Richard. Why not just go measure the globe? It's not that hard.
It's not that hard. Okay, thanks. Why don't you?
I did. Thanks for asking. I measured it in.
Wait, no. Wait. You started in one point, walked a complete straight line, and returned to that point.
No, I was much smarter. Much smarter than that when I measured it. I was
much smarter than that.
I did it such a much smarter way than that. I mean, that's a some people do that for short distances, and then they do
for accuracy is what.
And then they
do
and then they do geometry after that.
Yeah,
but so start, I measured it 4 times in Minneapolis. Yeah, 4 times in Minneapolis. I measured it at Lake Tahoe. I measured it in Punta Arenas. I measured it in Antarctica, and I got the same number every time. Amazing.
You measured the Earth in all those spots.
Yes, I did. Got the same. I got the same radius every time. It was pretty cool. Mr. Awesome. Toffees has been a member for 24 months. Says, wow, 2 years of suffering. Kango44 says, Dick, did you build the computer or phone you're currently using? Twat.
Oh my God, you guys are hilarious. Nope. But I know they work because I'm physically using them.
All right, so knowing that something works is a validation. Okay, got it. Thanks.
No, physically interacting with
the
it.
Sun Express says
to manipulate it myself.
The Sun Express says has the smallest dickus revealed yet why he can't see the sun during nighttime flights. Well, that's a good question. Yeah, if you're on
see the sun during nighttime flights.
Yeah, so if you're on an airplane, you're way up above the surface. So the surface doesn't have an opportunity to get between you. You can't be like, oh, there's stuff in the way, right?
No. I love how that picture, though, the surface of the Earth is always in your field of view, though, isn't it?
No, if you point the camera up, it's not in your field of view. Clem says that
but
people
you know
like
what geometry says about a ball. The higher you go, the quicker it drops away from you.
Yeah, I've measured that. I've measured that myself as well.
When you're looking straight out, you're not even going to see the ball anymore. You're just going to see the black.
Of course, it depends on your vertical field of view of the photo. But yeah, I did in fact measure
at straight line of sight.
I also measured the dip of the horizon between Miami and Santiago. It was it was three
dips.
Yes,
so
the horizon dips as mandatory on a ball.
Of course it does, because you're above it.
And as not mandatory. On a flat Earth, a disc, as you describe it, there should be a slight dip. Oh, look at that! We got a kitty. Got the kitty.
Yes, the higher you go, the little bit at a time, it'll start.
A small amount.
Of view, of course. As long as you're looking straight ahead.
Yeah, so I measured it, and it matched the prediction of the globe and did not match the prediction of flat Earth. Clems says people like Dick probably never flown in their entire life. Have you flown, Dick?
Can I have my chair now?
I've flown lots. Jesus, and I've fueled aircraft. I took a helicopter ride.
You should get the Theodolite app on your phone and then measure the dip of the horizon when you're flying next time.
I'm not denying that the horizon is below eye level.
But geometry demands that it be a certain amount. Yeah, geometry demands that it be a certain amount for a globe and a certain amount for flat. So we can make predictions on that. Do real science. Real science.
It all comes down to eyesight.
No, your camera isn't your eyeball, actually. Your phone.
Oh my god.
Yeah, it's not about eyesight. It's about
Is the camera lens modeled after what?
After a pinhole camera is not, and
it's all modeled after an eyeball, because that's how you see things.
A pinhole camera is not modeled after an eyeball, and it sees the same thing as a camera that is modeled after an eyeball. So it has nothing to do. It has nothing to do with whether or not it's modeled after an eyeball.
Actually, a pinhole, doesn't it just focus the light more when it hits your eye?
It is not modeled after an eyeyeball. It's
Everything optical is modeled after an eyeball.
A pinhole camera is not. Denying it isn't a good look for you, which is fine with me.
Okay. What's a pinhole camera modeled after?
I don't know. Doesn't matter. Not an eyeball.
No, it doesn't matter. I don't know.
It doesn't matter. You are trying to assert that because something is modeled after an eyeball, it's all about the optics of human vision. But I've given you something that is a camera that gives the exact same results as eyeball.
Do you know why eyeballs are spheres?
Has nothing to do with what you're about to say, but go right ahead.
Do you know why eyeballs are spheres, or curved lenses at least?
Go ahead.
Because when the light hits it, it's focus. Flat surfaces,
good job. Has nothing to do with how far you can see, though. Nothing at all. All right, Jack Better says, now that Dick realizes... Hold on. Now that Dick realizes the contradiction right in front of him, the cope begins. You ask for proof, Dick. Welcome to math. There you go. I got one from... You
guys use the language to describe something. Okay.
From Eric Burns says, when a boat goes over the horizon, why can't I still see stars? Why can't I still see stars that are farther away than that boat?
What?
So what causes the boat to be blocked? Why can't you see the boat when it goes over the horizon?
Because it vanished into the horizon.
But why?
Optics.
Well, that doesn't explain anything. Just saying a word that doesn't mean anything. Like, give the actual optics, right? Like, don't just say optics. You gotta if you think you know more about optics than the rest of us, then go right ahead and say it. But you'd need to do more than just say the word optics. You'd actually have to, provide something. So, all right. So yeah, Dick, here we're seeing a boat. So now, all right. So that boat, you just see that very little top of that little Y-shaped part. Why is everything below that blocked?
Hello?
Yeah. Hello. So, can you see this?
Hello?
Oh my gosh. He can't hear us.
Hello?
I can hear you, Richard.
Okay, sorry, log dropped out there. So.
Yeah. All right. So what's causing? What's the specific part in optics that's causing that to happen?
I don't know how to say it any differently.
It seems that you don't understand. That's what I'm getting.
Yeah, go with that.
Okay.
You see the crisp horizon?
Happily. Yeah, very crisp horizon. It's not all blurry. It's not, we're not seeing miraging. We're not seeing vertical compression. We're not seeing a haze because the horizon's too far away. Yeah, none of that.
Hello?
Oh my gosh. Hello? Hello? Hello?
Damn it, what's going on here?
Yeah, you're getting some boomer problems here.
Let's go over that.
Man, boomering the today.
Satellites must not be working up there.
Are you on a satellite phone?
No.
Well, then why would you say that?
I can see a tower though.
Yeah,
It's on a mountain.
yeah. Cell phones are except for the newest ones, like from T-Mobile, they're not talking to satellites. They've never talked to satellites.
Oh.
They've always talked to a local cell tower. But when I was in Antarctica and I got a GPS signal on my phone, I did not have a cell phone signal at all. I could not make a call. I could not get anything. It was totally dead. And I used a
How did you call Nathan Oakley?
because we had set up our own Starlink satellite. But when we didn't have the Starlink satellite, nothing. It was dead. Totally dead. So it was satellites orbiting the Earth that we talked to Oakley, but also I brought a RF scanner so I could look up and read if there were any cell phone signals. So I checked the different cell phone frequencies, 900 megahertz, 1.8 gigahertz and higher, and it got nothing, completely dead in those frequency ranges. And yet I was able to get a strong GPS signal. So BM Furball says, if you can't explain it to a child, you don't know it. You don't actually understand what you're trying to explain. There you go.
Absolutely agree.
Yeah. So what's causing? Good. Awesome. What is causing the bottom of that boat to be blocked?
Again, it's how your vision works.
Go ahead. Explain how your vision works.
Everything around you converges into a point.
That's not how your vision works.
What do you mean? What?
Yeah.
Yes,
Could you give a citation in
Can
a?
you explain how optics works?
Yes, I
Can you explain parallax?
Yeah.
Can you demonstrate it?
Yeah.
How do you do that?
Yeah. Well, if you take your finger and
Yes,
for
exactly.
people that aren't blind in one eye, you can look and you can close different eyes and you can see that your finger in relation to distant objects are in different spots. Now, parallax has nothing to do.
Do you know why that is?
It's because we have two eyes. Down here, this is not parallax.
But why is one lined up and the other isn't?
Because of the position. That's just geometry.
No,
So
because you have a dominant eye.
oh, I didn't know that.
When
I put it in the middle.
Looking at an object and you put your thumb in, you cover the object.
I put it in the middle.
One eye and then close the other eye. When you close the eye and then your thumb isn't covering the object anymore, that's your least dominant.
That has
eye.
absolutely
Your
nothing to
eye-
do with the camera. That only has one lens on it, so has no application to this particular thing here. So why again, and you seem to not be able to explain it, even though you completely agreed with BM Furball when he said if you can't explain it to a child, you don't actually understand what you're trying to explain. So try to explain as if you're explaining to a child. Let's imagine there's another flat earther here, and you want to explain to them what is causing the bottom of that ship to be blocked.
Perspective.
Go ahead.
Perspective.
Explain it. That's just a word. Go ahead.
I would tell a 5-year-old that's how your eyes see things in the distance.
That's it.
There's
Okay.
a limit to your vision. There's all kinds of variables involved if you want to get technical, but you're 5, so
No. You're explaining it to another flat earther. Okay, so now tell you what. Explain it to me. I have taken multiple classes at university and understand geometry, optics, and physics here. Go ahead.
you've taken art class?
This isn't art class though.
How do they teach you how to draw an art class?
This isn't art class. This is science class.
Perspective is art class.
This is science class though. This isn't art class.
Science class. Which science? Can you be a little more specific?
What you pick, but it's not art. This isn't art class.
You pick. Okay,
So you
I
said
picked
it's
music
optics.
theory.
So optics. Let's go with it's optics is the science class. Go ahead.
Optics. Okay, perspective.
Perspective
teach you
is
in
not part of perspective is not part of optics class.
Oh my god.
You didn't know that?
Perspective isn't part of. There's an optics class.
There are, yes.
Oh.
There's entire
Okay.
textbooks on optics. Newton wrote one.
I wouldn't trust that guy's eyeballs, but okay.
Okay, so you can't explain it. Okay, no problem. I have no problem with your inability to explain
I would
it.
tell a 5-year-old that's the limit of your vision.
But I said explain it to me
Notice how the
now.
horizon rises up to about halfway, and the sky about halfway.
Actually, the horizon
Look down
jumps
a long
all.
hallway, and the walls and everything.
The horizon jumps all over the place in
ceiling
this series.
Converge into one single point of
Hey,
your
Dick.
vision.
Hey,
Your
Dick.
dominant eye is lined up exactly in the center when you're looking straight ahead.
Hey, Dick. The horizon jumps all over the place in this series here. Oopsie. You didn't pay attention to that.
That means it's not physical; it's optical.
No, it's just because the angle of the camera was changing.
No,
Harnold
because
says,
if it was
Professor.
physical, it
All right,
wouldn't jump all over the place, would it?
Yes, it would. It depends on your camera. Harnold says,
It depends
Professor
on your optics.
Professor Phil is a true educator with the patience and grace of a saint in the face of someone who has no interest in reciprocating honestly. Well said, Harnold. Zero
Well said. Where's the
reciprocation.
proof of that?
Zero reciprocation here. Jack Fetter says copamine, a neurotransmitter unique to flurfs that when triggered blocks logic flow in the brain, triggering derp reflex mechanism.
Yeah, all the same crap.
There you go. Penguin J says, hey, Dick, I don't care. All right, we got Rick says, someone who doesn't care what others think wouldn't use so many cop-outs. Oh yeah. Got it. Caught you there.
Name one.
Jack Fetter, I'll just let the audience reminisce. Jack Fetter says, very weak dick, flaccid, you might say. Limp dick. Dang. Tough. It's a tough crowd,
Not
Dick.
at all.
It is a tough
It's
crowd.
always a tough crowd, full of liars, and they never said anything right about me once.
All right, here we go. Just a second. I gotta.
Never even quoted me correctly.
It's all good. It's all real good. Wayne,
Yeah, it's
not
all good.
Wayne.
Lying about
That's
people's
not a.
output.
Okay, hold on. Wayne, that's not a dick. Says Richard's thinking is the real fallacy. He spelled fallacy with a PH. It's hard to be this ignorant. He really supports his educational dysfunction. There you go. And then again, Wayne, that's not a dick, says, please donate to some man's ED charity.
I'll stop sharing this, Michael, okay?
Okay. This some ED charity. Cavafax says this money better not go to charity. Now, I don't partake in hookers or blow, so I can guarantee the money won't go there. But I tell you what, maybe I'll earmark the money I get from this live stream to my
I'm Canadian, so
to the
by
next
default,
time.
I have to
The next time I go out to an
Well.
Indian restaurant so that I can increase the methane percentage in the atmosphere.
Yeah, there's not much of it.
No, not very much. Calder V says, Dick, how's it feel to be stupid by choice?
Awesome.
It feels awesome. You heard it from him. Emerson Biggins says, Mike, You should make it conditional going forward that Dick change his name to I don't know to participate in your channel. I mean, you got an awful lot of I don't know. Right? You got
intellectually honest.
Like you don't know how optics work. You don't know how perspective works.
Everything. You guys know everything. You're super smart and special because teacher told you so.
Well, we do know a lot of things. We do, yeah. Phil and I do.
Yeah, you know everything about.
No, not everything.
Except about nature.
Phil.
You don't even know how eyes work.
I got a question for you, Phil. Do you know how to crochet?
No. Vaguely.
I don't. Yeah,
I've seen my wife do it with ease, and I'm thinking you have magic fingers.
It's just a big complicated knot, but I don't.
It is.
Yeah.
It is.
So neither do I. And so here, two of us, we don't know everything. We don't know how to crochet. And I can say, and Phil, let me know if somebody were to come to me and say to me that you don't know how to crochet, to me, if they said that to me, I'd be like, yeah, you're right.
You're right.
Do you? Yeah.
Of course I don't.
Now,
but if someone came
here's the problem.
Say you and said you don't know what the sun is, oh, there's a whole different ballgame. Attack them and hate them.
We do know what the sun is.
Call them stupid. And
Phil and I do know what the sun is. So now here's the thing, Phil.
No, you don't.
Would you go to a YouTube channel, jump in the live stream of the YouTube channel that is teaching people how to crochet, and then get in there and say, you're doing it wrong? Would you do that based on your knowledge of crocheting?
Definitely not.
I would not. No, I wouldn't either. But Dick has done that. Dick, who doesn't know anything about how to measure the shape of the earth, has come onto a channel where we do know how to measure the shape of the earth and declared that we don't. How silly is that?
You guys know how to measure the shape
Dick,
of
can you tell us why you think we don't know what the sun is? Dick, what's your evidence for that? Why do you think we don't know what the sun is?
Because you can't physically interact with it, manipulate it, touch it, smell it, taste it.
But we can measure its light and its energy.
There's other ways.
So what?
That's how we figure it out.
Smart people have figured it out.
That doesn't tell you what it is. That tells you what's coming from it. It doesn't tell you what it is.
But smart people have figured it out.
Yeah, people you trust. I don't. I think they're full of shit. But you guys believe them. You just believe them. That makes sense. A ball of gas and surrounded by nothing? Oh, fuck. Yeah. All the time, all day, every day. Balls of gas everywhere.
So Dick, I didn't ask you this question, but you are actually interested in learning anything?
I'm very interested in learning.
Well, I could teach you how we know that. I can teach you how we know that what the sun's made out of.
Okay, go ahead.
I'll teach you that. Okay, so.
Wait. Before though, he needs to commit to wanting to learn.
Yes, that's a good question. That's a good way.
I just told you.
Okay, so Dick, basically the sun emits light, which you agree we can see, right? So what we do is we have an instrument called the spectroscope, which can measure absorption, okay, of particular wavelengths. And what happens is, so what it does, it creates lines in the spectra. So the spectra is like looking at a rainbow, okay? And it creates these lines in the spectra. And the thing about it is, these lines are like a fingerprint for particular elements. So how do we know this? When we use a spectroscope and we look at something that's over here, in other words, we energize it to the point where it becomes a plasma, we can have a look at it and we see, okay, this is what the spectral lines look like, these absorption lines look like. And then we pointed at something else, it's different. We pointed at something else, it's different. Then we say, well, can we make a prediction? Can we use this technique to make a prediction? Well, we make a prediction, and then we aim it at a particular thing, and we say, wow, our prediction matches. because now we know what the fingerprint for this particular element is for each of these elements. So we aim it at the sun and we say, wow, have a look at that. That matches hydrogen. That matches helium. Wow, okay, there we go. We know what we know what that light comes.
No, stop.
It's from there.
You took light from the sun and determined it was hydrogen.
Absolutely.
Yep.
And you don't think that's crazy?
No.
So you pointed a light, or you pointed this spectroscope at Polaris and determined it's what?
They're the same stuff as our sun, basically.
So it's hydrogen too. Or is it a rock? Or is it a ball of water?
No,
or is it a ball of a different gas?
Water has.
Or is it a ball of gas that we
water
don't
has
even
a
know?
water has a different fingerprint.
No, Dick. You had it. Dick, you had a chance to. How often in your life would you actually be able to talk face to face to an academic? It would be rare. Why don't you not, Dick? Richard? Why don't you not squander this opportunity?
Well, he has.
Thank you very
yeah.
much for that. For that.
Dick, you pretended. You pretended that you wanted to learn.
You're special, right? You're special. You know more than everybody else.
More than a lot of people, yes.
Yeah.
In my particular field.
Okay. So do I.
Good. I'm happy to learn what you. I'm happy to learn what you know that I don't know. I'm not interested in growth.
What field? In what field is your expertise in?
I don't know. I'm done a lot of things in my life.
Have you
become good at?
Typically,
I became good at it?
Eight
because
years.
It's practical.
Yeah,
hands-on shit.
Yeah, so 8 years is what people say often is what you need to be considered an expert. So have you done any particular thing for 8 years?
Lived in nature.
No, I mean, you said, beyond it, yeah, something you've done. So, have you had a career that's spanned 8 years?
No.
Okay, so you didn't fuel airplanes for 8 years?
No, about 4.
Okay, so halfway maybe to that 8 year mark. So
are you telling me I wasn't good at my job?
No, I no, you didn't, you weren't listening. I said, typically people say you need 8 years to be considered an expert in a field. And so I'm just trying to find out what kind of field you might have that you could be considered an expert in.
An expert fueling planes.
Yeah, so within your 40s, there's probably a few things that you've done, you've put in 8 years of time into somewhere. I'm just guessing. So you probably are an expert in something. I'm just trying to figure out what it might be.
I wouldn't say I'm an expert at anything.
Yeah, but if you've done something diligently for 8 years, I would say you're probably an expert in it. If I've done something
diligently for a year, I can become an expert at it.
No.
It depends on what it is.
No, you can't.
Was I good at it naturally?
I didn't say good. I said expert.
There's so many fucking variables involved. These questions you guys have are stupid. Literally stupid. You guys, what is intelligence to you? How would you define intelligence?
Yeah, it's another rabbit hole.
No, it isn't.
That you're trying to.
Related to this. You guys are questioning my intelligence. How do you define intelligence?
So this is.
How do you define?
Let me help
coping mechanism. But go ahead.
Let me help with this one. I'll tell you how you pick someone who's intelligent. Okay. Number one, their ability to learn, but more importantly, their will to learn. In other words, right here, you have sitting in front of you somebody who's spent more than 50 years as a scientist. You could ask me all sorts of questions that interesting things about how things work. And I've given you some information. I've explained things to you, even things that are just common sense. They don't require any scaffolding, academic scaffolding. Are you a person who's willing to learn and say, gee, I'm really glad I had that opportunity? You see, Richard,
If it interests me, sure.
people pay a lot of money for me to say what I say to them. A lot of money. I'm giving it to you. I'm giving it to you for free. All you have to do is
Just have to be willing to
money
learn.
makes you intelligent. Depending on how much money you make, that makes you an expert or intelligent.
no. It's not that. It's
I would say
all the time I've spent.
Can I? Phil probably makes less money doing the things that he did than he could have done elsewhere in a non-academic field. So typically, academics don't pay as well. So it's not about how much money you make.
It's a vocation. I want to be an educator. Okay. I want to be a researcher and I want to be an educator. All right. That's why I do it. And I'm here. I'm here for the education. Okay. I'm hoping that at some small level, I can pass on something to you, Richard. Okay. Hopefully you understand now.
Okay, yeah.
It's possible to understand
I'll
what
give
the
you
sun
that.
is made out of.
I'll give you that. What if I disagree with you? What if I don't? What if I can't find the logic in what you're trying to teach me, and you say
That's okay.
you know?
I can't give you a course in spectroscopy in a few minutes. Okay, you need a lot of underpinning to be able to do that. I need to explain to you where photons come from. You don't even have that basic knowledge about how a photon is created. If I had all the time, I'd be able to help you. I could explain to you. This is how photons are created. This is why they have absorption spectra. This is why we can use those absorption spectra to differentiate between elements.
How is a photon created?
Okay, in a nutshell, Richard, hopefully you'll take this and you'll be able to explain it to someone else as well, or in a rudimentary way. So basically, when an atom is excited by some sort of by energy,
listen, don't talk.
Okay, so when an atom is excited by some sort of energy source, it could be heat, what energy source, the electrons are raised to a higher energy state. Okay, so they have their normal ground state at which they're happily working at, but then when you energize them, those electrons are forced into a higher energy state. So you've added energy to the atom. But now it can't be like that forever. It's going to give back that energy. Okay?
Yep.
So as it comes back down to its ground state, okay, it gives back that energy in the form of photons. Okay? And now where it ended up, where it began at its ground state and where it ended up, and the amount of energy that it has to give back in order to get back to its ground state determines what its wavelength is. Okay. So this is what creates. When you see light, Richard, this is what's happening. This is what you're looking at. Right before your eyes, Richard, you're seeing this process happening. Okay.
Does that make the world a ball?
That doesn't make the world a ball. But hopefully, Richard, today, if you've learned nothing, you've learned where a photon comes from. Okay?
Where does the sun get its energy?
Okay. The sun is a nuclear, like a giant nuclear reactor, fusion reactor. Okay.
Okay.
So this enormous amount of pressure.
Where does the pressure come from?
One thing at a time. Hold on.
Gravity.
Dick, one thing at a time, Dick. You asked a question. Don't ask the other question until he's done with the answer. Be polite.
this enormous amount of gravitational attraction, that pressure that's being created in there, also creates an enormous amount of heat, and this heat is enough to strip atoms off their electrons to create a plasma. Okay, now as this pressure is going on and on, more and more, there's enough pressure to be able to fuse hydrogen atoms so that they now create helium atoms. So you remember, hydrogen is just a proton, okay? Just a proton, all right? But when you smash them together, some of these protons become neutrons, and as a result of all of this fusion reaction, we end up hydrogen being formed into helium. Now, as this progresses, the sun's actually going to get cooler and cooler, right? So eventually, none of us will ever be there to see this happen, but the sun will die. Okay, and we'll be left
for
with
a long time.
Yeah, it's a fact, and that's why it'll die. Yes,
how are
that's
you
why it'll die. I've told you what the process is.
According to you.
Yep, I've told you what the process is. Okay,
so sun dies, Earth dies. I don't believe that's possible.
The extension of that process. In other words, if we look at what's happening and we say, well, what if this process continues? What's going to happen? Well, if this process continues, the hydrogen, in other words, the fuel, will all get used up, and then the sun will no longer be able to be this fusion reactor that's producing all this wonderful light and energy for us.
Where is it getting its hydrogen from?
What oxygen?
Hydrogen, he said.
Where is it getting its hydrogen?
It's hydrogen. It's hydrogen. It amassed all this hydrogen.
Remember, the black stuff is nothing. It's just space.
There's over billions of years, it actually captures all of this.
Billions of years.
There's enough of it. It's not just empty. So outer space is not empty. Okay, there are still gas particles around.
From billions of years ago.
Sorry, say you get.
You have the paperwork from billions of years ago.
No, but we can have a look at what's happening and then work back what did happen. Okay.
You can assume what's happening and go.
No, we know what's happening. We know what's happening. So what we do is we use our knowledge about it. We know what's happening. So why can't you even just be respectful as a learner?
Oh my God. I'm rejecting what you guys are telling me because you have no physical evidence of any of it.
But there is.
What is so difficult to
There is
understand?
evidence for these things.
There isn't. According to you guys, yes. I said physical.
He doesn't have the time right now. This isn't the venue for going over that actual evidence.
He said, I thought you'd be a little bit different, Richard, but no, here we go.
No,
you thought I would just accept your beliefs?
It's just blind faith denialism. It's the same standard.
I just
flurf,
thought you'd be interested in at least some of the physics anyway.
He said
you're not showing me physics. You're giving me maths and
he talked about common sense. Actually, there's no math presented.
Do you even know what physics means?
Yeah, so you're not the one. You're not the one to.
Without physics,
you're not the arbiter on this.
There's one last thing, Michael. There's one last thing I wanted to.
All right,
that's
shush.
The point.
Dick, shush. Yeah, Phil.
One last thing I wanted to show.
Shush. I've shut up.
One last thing I wanted to show, Richard.
Okay.
All right, just one last thing I wanted to show, Richard. So this is going to. I'll share this, okay. And the reason I wanted to show it to Richard is because I'm actually, to be honest, I want to show it to other people, right? Okay, because this is one of the beautiful things about what you guys did going to Antarctica, okay, all right, and seeing what you saw. It's the definitive proof that we must be on a ball. We must be living on a sphere, okay. So let's have a look at this. Okay, this is just beautiful. Okay. So you can have a look and you can see this, what I've shared over here. Okay. All right. Okay, so this is a globe that I've got over here. It's a professional globe. Now you can see,
Professional.
so you can see Australia down here. So Richard, this is for you or not for you, doesn't matter. Okay, all right, you can pay attention or not pay attention. But so here we see Australia down here. Okay, now I've set this up so that this is actually midnight at Punta Arenas where you guys were, and you can see that the Terminator line right there.
Yeah.
So in other words, it's dark. It's dark at Punta Arenas. Okay, but it's just light right at the edges. So you can see that no matter what, if this turns as it does, this area here, the larger area of Antarctica will always be in light. Okay, it's not going to change. It's not going to get dark. All right, so I could spin this around and that'll always stay dark. Now, but the thing is that when you people were over there, in particular, I was watching. I think it was pretty sure it was a live stream with Jaren and Whitsit. And they're looking straight down south, and Jaren was commenting and saying, wow, they could see the glow of the sun directly south. They could see the glow of the sun. Yeah. And when Jaren said that, I knew his heart must have sunk into his boots, because he must have known right there and then there had to be the 24-hour sun in Antarctica. He was looking at it. Yeah. He didn't even have to get on the aeroplane to go there to see it. He could see it. He looked at that and said, my God, they are right. They have to be right. Because that sun, what he's looking at, that glow, that sun is actually over Australia. It's just almost over Australia. That's where that sun actually is. Okay, so you're looking at that and thinking, well, how can the sun be over there?
That's where it's observed.
That's on the other side. Just be quiet, please. I'm talking to people. That's on the other side of flat Earth. How could it possibly be going? Look at that. It's straight across there. Of course, it's around Australia, on the Tropic of Capricorn at this time. Okay.
Yep.
So in other words,
how can I see it do the same thing where I am?
I don't know where you are, Richard. Ask me that question in a good way. I'll answer it.
Again, where I am, the sun did what it always does. But you tell
what does the sun do? What it always does? What does the sun do? What it always does? Tell me about that.
Rising in the east and setting in the west.
Well, of course it does that. We know that.
Moves right.
Fact, it's not always like that. It just recently did, though, didn't it? Did you follow it just recently? You know, on September the 22nd?
21st, but okay.
Yeah. Did you follow it?
What do you mean follow it? It did what it always does. Circled me. Or, well, didn't circle me. It does.
So where's the sun at? I
can't see it circle me.
Are you below or above the Tropic of Cancer?
I'm at about 55 north.
Okay, so you're pretty high, pretty up north, yeah.
Sure.
Okay, so you could only see you'd have to look south to see the sun, wouldn't you? In a southerly direction, wouldn't you?
I look.
Yes?
I'm just trying. I'm outside right now. It's cloudy, patchy cloudy, though, so I can't even see Polaris.
Well, during the day.
I look more left than I do south. Straight.
During the day, the sun goes across, it goes overhead, but at an angle for you, doesn't it? Because you're north of the Tropic of Cancer, so you can actually see the sun as in the south, can't you? And the sun goes down, dips below the horizon, and dips on the other horizon, doesn't it? But you know something, Richard? An intelligent person would look at that and say, if the Earth is flat, why is it not going horizontally? if it's going around my head? That's
No,
what you've got to be asking yourself. An intelligent person would say, how
the
could it be
sun is
going?
moving.
How can it go down
You
below
guys
the
look at
horizon?
it and think, oh, the sun's stationary. It's the Earth.
We don't think
that's moving.
the sun's stationary. We don't think that.
Oh, you don't?
No, the sun is orbiting the Milky Way.
The sun isn't relatively stationary to you guys?
It's orbiting the Milky Way.
Oh, okay.
Richard,
So it's moving.
Richard, why isn't the sun traveling? If you're looking at it south,
anything's moving.
Richard, if you're looking at the sun and it's south and you're southern, it's south, why isn't it going horizontally?
God, this horizontal.
Why does it go below the horizon, Richard?
It doesn't go below the horizon. Is the sun not always above the Earth?
No, it's not.
No.
What do you mean? No, it's not.
No, it goes below the horizon.
It goes below the Earth?
Below the horizon, everybody can see that.
Is that okay? You're not answering my question. Does it go below the Earth or not?
It goes, the Earth's a sphere, so it goes around.
Yeah.
Does it go below the Earth or not?
There's always a point
the
that's
answer is no. People.
that's cheap.
The answer is no.
Yeah,
Can
you're
the
describing
sun
the
be visible
globe.
to anyone on Earth at any given point in time?
You're describing the globe here, of course.
Can the sun be visible to any person on Earth at any point in time?
About half of the Earth can see it.
Yes, exactly. So it's always above the Earth.
Yeah, but it's below the horizon for half of the Earth.
Explaining to a 5-year-old, if I explain that to a 5-year-old, they'd go, "Oh, yeah, okay,
half
that
of the
makes
Earth.
sense. It's always above the Earth."
All right, so for half of the Earth, the sun is below the horizon at any time.
But
See,
it's
Richard,
below the Earth.
Richard, for me, the sun is still in the sky. Okay, for those, for other people,
It's
for
set
other
here.
people,
Yeah.
if they had where you are now, if you had an equatorial mount, and you were tracking the sun, it would be facing the ground. Your equatorial mount would be facing the ground. It would be as if it was underneath you.
But is it underneath me? No, because it's above you, isn't it?
No, it truly is. Yeah, it's truly below.
It's truly below it again. So you guys believe the sun
you
goes below the Earth.
You can get the
stupid to me.
Skyview app on your phone, and it knows your location and the orientation of the phone, and so you can point it to where you can be like, oh, the sun is right there right now,
and it doesn't always match what I see.
That's never failed for me. But
okay.
All right, let me add a few more things to read here.
Yes, go ahead. I'll stop sharing.
Yeah, thank you.
It's a beautiful picture. I hate to stop sharing this. Who doesn't want to see a picture like this? Gorgeous picture. Yeah.
All right.
Nice
Melodic lyrics says a really good one here for Dick. Why do stars show the same absorption and emission lines as elements in the lab when viewed with the spectroscope? So, I mean, he was talking about this earlier, but this is how we can confirm it, right? We do independent testing. So we take helium in the lab and we look at the spectra of helium in the lab, and we take lithium in the lab and oxygen and nitrogen and carbon dioxide, and we get spectra emission lines for all these different elements in the lab. And so we've got their fingerprints. And then we take that and we look at the sun and we say, oh, you know what? That is a combination of these different fingerprints. And we look at a different star and we say, you know, that's similar, but there's some differences. These other spectra are represented more or less in this particular star. So that's how we know it, and that's how we have evidence for it. And this particular topic, though, you could take, you know, multiple university level courses on this particular topic alone.
Hydrogen traveled 93 million miles.
No, the light did.
Oh, so not hydrogen.
The light that was emitted by hydrogen, or the light that was blocked because of the presence of hydrogen. Two different.
Light that was emitted by hydrogen.
Yeah. No. Phil taught you how photons are created.
No, Phil gave me an explanation.
Yeah, Phil taught you the truth about how photons are created.
No, he gave me his explanation.
So
the same explanation he was given as a child.
Well, I mean, I don't know if he got it as a child.
I still have not been presented with any physical evidence that gas can form a
photodynamics.
sphere.
Yeah. I mean,
Naturally.
you saw photos of it. All right, Wayne, that's not a dick, says Richard. How big is the Earth? Don't lie about the size. All right, how big is the Earth?
As big as God made it.
You don't know. Got it. Wayne, that's not a dick, says video title should be Tune in to watch Professor Phil Bell beat a Richard live on YouTube.
Yeah, they're beaten.
The double entendres are flowing tonight. Jack Better says dominant eye, WTF, confirmed. Dick be dumb. Yeah, it has nothing to do with dominant eye. Why did you bring that up? That's almost like old man Yamaha talking about the tying the yellow onion to his belt. Foxworth Kerman says, what about 2-point perspective, Mr. Art Dick Wayne? What about that? What about 2-point perspective?
2-point perspective?
Yeah.
Well, tell me what it is.
Apparently your art class didn't go that far. All right.
I never said I took art class.
All right. Well, you deigned to try to educate us on art. Nope. Having never taken an art class.
I tried to simply tell you how your eyes see, and you reject it.
And you failed. Hugh Jar says Richard is not honest. His mother's maiden name was Kerr, so his full name is Dick Wayne Kerr.
Leave my mother out of this.
Dick Wayne Kerr.
Attack me, don't attack my parents.
That's funny. Wayne, that's not an X, says Professor Phil says good eye might. Good eye might. Oh, good eye might. How's my Aussie accent there? I think I got it finally. Rossi says spectroscopy needs a container, but Dick sees a container, so we can do spectroscopy.
Yeah, you guys sure can.
All right, Jack's brother Jim Daniels says NASA's Parker Solar Probe became the first spacecraft to fly through the corona, the sun's upper atmosphere, in 2021. And no, it's not beer that it flew through.
Yeah, you guys think things have been sent 93 million miles.
They have been. David says, if one has to touch, manipulate, and taste the sun in order to know the sun, then how does one get to know Richard?
Just like this.
But we're not tasting, touching, and manipulating. I guess you know what? I gotta give credit where it's due. Phil, you have been manipulating him all night.
93 million miles away.
It has been a master course in manipulating Dick. It sounds so funny. That is so many wrongs. RT96 is David with a Perkin-Elmer 3030 atomic absorption spectrophotometer. There it is. Perkin-Elmer 3030. I'm assuming that's a particular.
Full of all kinds of knowledge.
Actually, I've got a story on that. That's fantastic because when I first graduated, we ordered one of those AAS atomic absorption, and you in those days you had to put a sample in. So you put your standards in, so you could see what the curve looked like. Then you back up. Explain what is this process of putting in the standard, right? People aren't going to know. Okay, all right. So basically, the reason for a standard is because if you're looking for a particular type of element, let's say for instance this is a sodium, you're looking for sodium or magnesium or gold even, all right? Doesn't matter. What happens is they will emit at a again using the wavelength of light. So once they become a plasma, they will emit photons at a particular wavelength. Okay, their fingerprint. Now, so what happens is you then put in the known thing, so you can see this is exactly what the absorption should look like. okay, for that particular type of element. And now you get your sample and you start putting it through that. And when you see things that match, you look at that, you look at the amount that there is, and then you can say, okay, I've got gold or whatever it is, and I've got this much of it, this many milligrams per liter in this particular container of it. Okay, so we had this machine that's just arrived, and it was actually pretty much invented here in Australia, and we had a Hewlett-Packard version of this. The other one was Perkin-Elmer; they were the opposition. But I think the people who actually belong to Perkin-Elmer actually did most of the work on it. But anyway, we had one. But the problem was, you put in a sample, after you put the standards in, then you put your sample in one at a time. This was a laborious process because it had what's called a rat's tail, so a thin little tube that used to go inside the sample and suck it out. So it would suck it out, and then this acetylene flame would energize it. You know, turn it into the plasma so that you could, so it would the spectroscopy part of it could work. So one of the things that I was fortunate, I was a bit of a programmer. So when calculators first came out, the Sharp calculators you could actually write basic programs in BASIC in them. And they also had an RS-232 input so that you could get a signal to come into the calculator, which is fantastic. So they don't even do that in calculators anymore, but they did it then. So anyway, so what I did was I worked out how to get the signal from the AA. So instead of having to write it down, because that's what people had to do, they put the rat's tail in, they got the sample, they wrote down the absorption. So you had to write down, next sample, write it down, next sample, write it down, next sample, write it down. So what I did was I got the signal from into the calculator, and then I was able to output the calculator to a printer. Fantastic. We now had a throughput, so RS-232 coming from the machine into the calculator, running through my basic software, and then out to another RS-232 to output to a printer. So there's a little story about atomic absorption spectroscopy.
So what was the calculator?
Hewlett-Packard. It was a Hewlett-Packard. I think it was 121 or something, a little thing.
Okay.
Yeah. I can't remember exactly the model number, but it was one of the few calculators that just came out. Because remember, in those days, calculators only came out after I started at university. So before then, all we had were the slide rules and the four-figure log tables, the green book, you know, that you say. So if you wanted to look up sine, cosine, tan, and all that, you went through logs. So they had every single degree, and you could look it up. You know,
I've got a trig slide rule right here.
Oh, fantastic! Yeah, there you go. So we had those things. That's all we had. There was no calculator, so you had to be pretty proficient at using that slide rule, in exams. But then later on, these calculators got invented. So we thought, this is crazy. You just press a button that says cos, and it gave it to you. You know, I thought, well, how good is that? You know, you didn't need a slide rule or and write down stuff and make other calculations. The calculator did all the stuff for you. So from then on, the Sharp came out with their programmable one. I'll tell you that the professors didn't know anything about programming. They were clueless, right? So at exam time, they said, "Oh, can we bring our calculators to these?" "Oh, yeah, no problem." So I've got a Sharp. But of course, I could program. So I wrote in BASIC, I've got my formula for this or my whatever I needed, and I just program it in. A, enter, and input A, input B, input C. Do this with A, B, C, and out comes the result. How good was that? Of course, they cottoned on later on and said, no, not allowed to have those type of calculators in.
You probably learned more writing the code than doing it anyway.
I hardly actually used it anyway. You're quite right. So, but writing the code meant but it was fun. It was fun doing it, and then going into the exam saying, I've got the tools that I need.
When I was in high school, I took advanced algebra 2, and we covered polar coordinate system, and I loved the different coordinate system. And I decided to write a program to plot out polar formulas. This was on my Apple IIc, so it took some. I had to transpose everything because the coordinate system on the screen isn't the same as just an XY with a origin in the center. I had to fix all that, but then also figure out the position in the polar coordinates. So I did the homework. The homework was draw out this particular formula. And so I did it, printed it out, and turned it in. And then my teacher was like, we didn't show your work. So I gave him the source code, and he failed. He failed me on that particular assignment.
So unfair.
and I'm like, well, I could do it again or not, because I'm going to get an A in the class anyway, so I don't care. So I got an A in the class. I got 0 points for that particular assignment, but I probably knew polar coordinates better than anybody else in the class after that section.
Yeah, exactly. Yeah, no, great. Well, there you go. That's how we learn. That's how we learn, Richard. That's how we learn.
Yeah.
Yeah, making mistakes is the best teacher, I'm aware.
Oh, totally.
I'll tell you what. I didn't make any mistakes there, though.
No, I know. You're perfect.
Richard, I've done more than 50 years of research and stuff like that, and I have made many, many, many more mistakes than I've got it right. Okay.
Of course.
Right. Okay. So yes, learning is amazing. Every day there's something different.
Yeah.
It's. Be happy to learn. People teach you stuff, and of course we can't all know everything. So there'll be groups of people who learn this type of thing and become experts at it, or experts at these different things. Okay, so what you do as an individual, say, well, pick the thing that you're interested in, and then find those people who spent their lifetime learning about it. I mean, how many people?
Why would I do that?
How many people, Richard, will you meet in your lifetime, right? Who has so intimately knowledge of the atomic absorption that would actually get the signal into an RS-234, output it to a calculator, then output it to a. How many people, Richard, would you ever meet in your lifetime who could do that? Who have done that?
0.
Exactly. Yeah. Savor the moment, Richard.
Dick doesn't even know what an RS-232 is.
Nope. And guess what? I've lived just fine without that knowledge.
That's sad that he revels in his ignorance. Let me move on here. Evil Producer 1 says, Weenie Wayne is an expert in Dunning-Kruger. He specialized in top left. There you go.
Did you fuel a plane?
Everybody needs to have some expertise, and I think we found what it is. The third Duras sister says, boats disappearing over the horizon vanish bottom up, but the top is farther from your eyes than the bottom. That contradicts Dick's explanation. It's some kind of magical optical distance limit. It does.
What?
Yeah, it does.
You guys don't think there's a limit to vision? This is retarded.
Well, if there is a limit to vision, then the top of the ship should disappear first, not the bottom.
According to your...
No, according to you.
Ball, yeah.
According to you, if it's because you can only see so far, then the top of the ship, which is farther away, should be the first part to disappear, not the bottom.
The top of the ship is further away than what?
Than the bottom of the ship.
So, Michael,
what are you talking about?
Richard?
Yes.
Sorry to interrupt you.
Are they not attached to the same hull?
Okay. I have some students doing their final exams who I have promised to tutor in exactly 12 minutes' time.
All right. So, I have one question for you.
Yeah.
From
Sure.
Leslie Rohrer says, can you tell what a flame is 20 meters away?
Tell what a flame is. Well, if I had if it had some sufficient energy and I had my spectroscope, for sure, as long as I could see it, as long as the spectroscope could pick it up, no problem.
There we go. All right, what were you? Do you have any more?
Yeah. So basically, I'd love to do more, but in, like I said, in 12 minutes time, I've got a bunch of students doing their finals, and I have promised to help them. So I guess I'll better do that.
All right.
All right. So look,
Thank you.
I want to thank you, Richard, for coming to this. We've been sparring on the chat for quite a while, and maybe I'm nuttier than you think, or not quite as nutty as you think. I'm not sure, but we'll see how that goes. But Richard, it was been a pleasure talking to you, and you were pretty respectful. I hope that you could actually, even though you wouldn't outwardly want to say that, that you've learned something, maybe you'll look back in time. Somebody will mention something about this, and you'll say, "Oh yeah, I remember, Professor Phil said something about that." So I'll look it up, something like that. Okay, there might be something in it. But hopefully, for those who are listening, the fence sitters, those people who think that there actually is something in this flat Earth thing, there are better ways to feel good about yourself, and there's better ways. In other words, learning is really the key to it, because it's a thing you adopt for all your life. Okay, and look forward to the things that you don't know, so that you can say, "Well, gee, I'm so glad that I've looked into this and I've learned something new every single day," and take pleasure out of learning, not out of wanting to be in a community that wants to feel like they know more than all the scientists that ever lived. You're thinking like, were they all fools? Well, all the silliness that you have to believe in order to believe that the Earth is flat. It's just ridiculous. I mean, think about it. And the other thing is, please have some self-respect. Okay, you owe it to yourself. And say, look, I'm not going to fall for this nonsense. I don't need that kind of company to feel good about myself. Okay, I don't need to pretend silly things in order to feel good about myself. So I think, Richard, I'm speaking to others. I don't know how you feel. Perhaps in your private moment, you might you might take some of that in. Okay, but anyway,
but.
Michael, thank you so much for the time. I really appreciate it, and I certainly enjoyed being here. Thank you.
Yeah, thanks for stopping by.
Dr. Phil.
No worries.
Dr. Phil again.
Okay, all right.
Thank you,
Bye-bye.
Professor Phil.
No worries. Okay.
And you were respectful for the most part as well. Apart from the couple of times I triggered you, but that's okay. We all get triggered.
Okay.
Yes,
all
thank
right.
you again for your time.
Okay, all right. Bye-bye.
All right, bye.
Bye.
All right, we got a couple others. If you want to stick around, or not, it's up to you. Whatever's fine. Inquisitive Infidel says, to have a valid opinion, you need knowledge. Very true. Yeah, I like that. Wayne, that's not a dick, says Dick's choice to participate in this date was a real boner. He's not a master debater. The double entendres. All right. Melodic Lyrics says math is how physics is communicated. That is correct. That is correct.
You guys are insane.
No, that is correct. That is how it's done.
There's nothing physical about math.
And so I didn't say that. Math is how physics is communicated. So I can give you an example.
Actually, okay, I can agree with that, actually, because math is a descriptive language. Yes,
Yeah.
you can use it to describe anything.
Yeah.
You can even use it to lie.
So, but just like English can be used to lie, people
Yes,
can go and
every
test
language.
it. People can go test it. And so since math is a bit more structured, it's easier to identify lies in it than in subjective languages like what humans use
I
to
disagree.
speak to each other.
It's just as easy to lie with math as it is any other language.
Yeah, it's easy to find
like the
stuff,
Earth rotates at 1,647 kilometers an hour at the equator. Oh, no.
That's just
It's
English.
actually 0.0067 RPM.
Well, they're I'll make the assumption that you're correct on that. Those would
They're
be
both
equivalent.
correct.
Yeah, that would be equivalent. So that the math there would be truthful in that instance.
Exactly.
So
you agree with me, finally.
all right. Lisa says, all right, you primitive screwheads, listen up. You see this? This is my boomstick. Shop smart, shop S-smart. You got that?
Yeah, I was a fan of Army of Darkness.
Got your boomstick. Thank you, Lisa. I love that one. So the question is to everybody.
Evil Dead 1 was the best.
Well, I was going to about ask that. Evil Dead 1 or Evil Dead 2 in the chat.
1.
1 or 2. So
That
Dick has
pencil
Dick
in
has
the
one.
ankle still haunts my dreams.
Jim Daniels, brother to Jack, says, and now it's time for the I'm a Real Dick show, featuring a barrage of asinine questions, bickering, fake laughter, and trying to overtalk others. Dicky Poo is back. Oh yeah.
I think that's a poor assessment.
Wayne, that's not a dick, says Dick has the Flurf STD, science thinking denialism, transmitted verbally and optically through YouTube and is highly contagious to the dumb. All right, we've got 1, 3, 2. It's either 1 or 2. So Evil Producer 2, my left boot, says 2. Glenn Mill says 2 because I can't agree with Dick. I agree. It's Evil Dead 1. It is Evil Dead 1. Then the next question: do you prefer Peter Jackson's first movie, Brain? What is it? Forgot. Or his second movie, which is Dead Alive.
What was that?
The Peter Jackson's first movie
I've never
is
seen it.
Brain Dead, or Peter Jackson's second movie. No, I'm sorry. Hold on. Bad Taste. All right. Bad Taste is the first movie. The second movie has 2 names, Brain Dead and Dead Alive. I think that's correct. I think that's the case. Let me.
Never seen either.
Wow. Well, Bad Taste, Brain Dead. Yeah. Brad Jackson's first feature was Bad Taste, a splatter comedy. And he did Meet the Feebles. I've not seen that. Anyway, Dead Alive. So I'm sorry. Bad Taste or Dead Alive.
I haven't seen either.
There you go. Also called Brain Dead. There it is. There you go. Put in the chat your answer.
Only ever seen Lord of the Rings.
Leslie Rohrer says, point out that helium was discovered in the sun first. Yeah, so that is an interesting thing. So spectroscopy had identified the Fraunhofer lines of helium from the sun before helium had been discovered on Earth. And so they saw these spectroscopy lines, Fraunhofer lines, in the sun, and they're like, what are these lines? They saw the hydrogen, like, oh, this is hydrogen, but what are these? And it was helium, and so they hypothesized that helium was another element, and then sometime later they found it. Pretty cool. Ashton Richards, I was speaking. I did not confuse Evil Dead 1 and 2. Those were not by Peter Jackson. Look up the early movies by Peter Jackson.
How dare you?
Yes.
Sam Raimi is no Peter Jackson. Or the other way around, sorry.
Saltex says, so why is the whole world lying to us? It's a good question. Why? How are they benefiting?
How are they benefiting from lying?
That was the question.
The ones who control the world?
That's the question.
Again, silly question.
Can't answer it. Got it. Jack Fetter says, I would have so loved to bounce question off Phil for an hour, and you just pissed it away. You dick. How tragic, you simplistic, cocky dolt.
Awesome.
Oh,
You guys
yeah.
are very pleasant people.
Yeah, you pissed it away. The Sun Express says, how curious for a dick to be so dedicated to the internet humiliation kink. BM Furball says, I misspoke before. If you can't explain it to an adult in 5-year-old words, find another adult. That adult/child will never actually hear what you're trying to teach. Yeah. Algorithm says, math is a descriptive language that has no ambiguity and includes a systematic means for knowing when someone is lying. There is no other language like it.
There's no other language like English either. There's no other language like French.
No, there are other languages like English. French is another language like English. Not nearly as much like English as Spanish, I think.
Derived from English?
No, they're romance languages, and you've got other languages that are Germanic in origin or
there's
Eastern
thousands of languages.
Yeah, but there's a smaller number of common sources to languages. So Rossi says that time Cece said he felt dick sitting in a park. Have you been to Westchester County, Dick?
Nope.
No? Oh, you should go. I
I wouldn't even know that guy existed if not for you guys.
You and CC like frolicking in around Westchester County would be quite something.
No, I'm not a fan.
You could frolic. Inquisitive Infidel says, how does Dick verify his info? Who are his experts? There's a good one. Who are your experts that you trust?
Not relying on experts. I'll only claim what I can physically test for myself. It's simple. And you just never get it.
Many times you made other claims. So, like for example, early on when you're talking with Phil, you said that celestial navigation works on flat Earth, right?
Celestial navigation works on Earth.
Yeah.
Sure.
But you didn't verify that. Right?
No. But I still got no trouble saying it.
But you should, because you just a minute ago said that you only accept things that you've personally done. So you haven't done celestial navigation. Right? You've never done it.
Okay,
yet you think it works on flat Earth.
Well then no, I think it works on Earth.
All right, so you're walking it back.
There
Okay.
are some things Good. By default I will trust, obviously. If I wanted to know more, I would go look into it myself if I needed to. But I don't need to show that the Earth is motionless.
Oh, but you do. Anyway, so you mentioned the YouTube channel A Plain Truth. And so people are wondering, is that Travis you're talking about?
Nope.
That's a different one?
Mm-hmm.
Because there is a guy, Travis, who has a channel called A Plain Truth. So that's a different channel called A Plain Truth.
This guy was on. Sorry, I'm outside and it's starting to really rain here. If you can hear that.
I can't.
Oh, okay. Good. No, he was A Plain Truth. He was the first original Plain Truth. He was on like A Plain Truth 12 before he passed away.
Okay.
Because he kept getting censored and shut down.
My guess is he probably, like other flat earthers, went off to other topics and got shut down. But the flat earthers
covered a
that
great number of topics.
the flat earthers that stick to just flat earth or stick to things that YouTube has not said will shut you down if you do this, they stick around. So there's plenty of them. So it's not that YouTube deletes channels that are flat earth channels. It's that YouTube deletes channels that do things that they say will delete your channel if you do this. Flat earth isn't on that list.
No. When you get too close to the truth and go against their narrative, then they'll shut you down.
No, and that's never happened, actually.
Yeah, it has.
Never has. All right. Vegan Problem Solver says flirps don't know meanings of horizon, vanishing point, angular size, perspective. Beyond horizon doesn't necessarily mean at or beyond vanishing point. Very correct. Very correct.
You can't hear that?
I can't hear. No, I can't. So Zoom has some pretty good noise canceling.
Oh.
Yeah.
Well, the rainforest is living up to its name.
The rainforest.
I live in a rainforest.
You live in a rainforest?
I sure do.
At 55 degrees north latitude?
Yep.
Pacific time.
Yep. Close to the Alaska border.
So you're in British Columbia?
I am.
Wow, all right. There you go. Are you near the water or are you inland?
I'm on an island, right on the Pacific.
You're on an island?
Yep.
Oh, dear. Graham Island?
No. Heard of it.
Stevens? Banks? Macaulay?
There's about 1,000 islands
I know. There's a
in
bunch.
the chain, so you can guess all day and then you wouldn't guess it.
All right. Well, there you go. And how do you get internet there?
Through the towers on the mountains.
Okay.
I don't know. Underground cables, I imagine.
Well, you're on a phone, right?
Yeah.
Okay. And you're using cell service?
Wi-Fi.
Your house Wi-Fi?
Yeah.
Okay. And your house has a cable coming to it?
Yeah.
Okay. So
That's what I said. Underground cables, I guess.
yeah. And somehow it gets to the island. Who knows how it gets to the island?
Underground cables.
Well, if it's a big enough island, they'll pull a cable. If it's not big enough and not enough market, they'll do it through towers.
One or the other.
Yeah.
Combination of both.
All right. Well, there you go.
There you go.
That's
Yeah.
all right. Oh, you know what? Conspiracy Music Studios made a song for you.
I know, he's been bragging about it.
Have you seen it?
Nope.
It's pretty amazing. He made a special version for me to premiere tonight.
Oh, great.
What do you think of that? Just for you. You are finally on the flat map.
I know. I got my Flurf Wiki.
You've got your what?
My Flurf Wiki.
Oh, is there a Flurf Wiki for you now?
Dick Wayne, unknown. Oh, but he does this. He says this. He
Wow,
thinks this.
you are really moving up the ranks here, Dick. I'm proud of you.
I know. You guys hate me because I defend myself.
Let's see. I'm going to try to get Conspiracy Music Studios channel. I'm going to pop it up here in the description or in the chat so people can go and have a look at it. So, all right, here we go.
Are you going to premiere it or whatever you
I
said?
am going to premiere it. So Jay Donachie says, I was 5. My dad said that the earth moves around the sun does not set. It took me a minute, then I realized, yeah, that works out. 5, smarter than Dick. Yeah. There you go. All right, well, Dick, thanks for stopping by. It's been real.
Sure.
And let's see.
Okay.
All right, that's it. Bye. All right, everybody else. Next week we were maybe going to have Awake Souls and Limitless, or Ronnie and Jason, but they did not want to do a scientific debate. Scientific debate being, we do science, hypothesis, compute the consequences, compare to observation. They didn't want to do that. And so they're like, nah. So they took their toys and went away. So that's fine. That's not on the schedule for next week. Maybe they'll change their mind, but I kind of doubt it, because no flat earther can actually do science. Because when you do science, what they're going to have to do is provide a hypothesis and a computation from their model. And you can't, there's no flat earth model that works. Multiple flat earthers have tried, but they've never actually put forward a model that works. Now, we, of course, can. Rossi says audio spectrometer says Dick Wayne equals Hans Wormhat. I don't know about that. But the globe can use the globe model, compute the consequences to make a prediction about things that we've never done before, never seen before, or things that we have seen before. Either way, it does have the ability, the globe does have the ability to make a prediction. And I'm happy to test that and compare it to observation or reality or experiment. Flat earthers will never do that, because they know every time flat earth is scientifically tested, it fails 100% of the time. So, well, we've got Old Man Yamaha. So tell you what, Old Man Yamaha. All right. Watch this, Old Man Yamaha. You're gonna love this. So I will pull this up so that people can see. Let's see here. All right, before we go, so Jerry Two Teeth is no longer Jerry Two Teeth. He's now Jerry No Teeth. He pulled him out. So there we go. I'm just getting ready so we can look at it. So this is this has the actual format that I sent over to Ronnie and Jason. So anyway, here's the page, Johnny. So you can look at this. Two Teeth, No Teeth, Jerry No Teeth. You can look at that. Here is, here's their silly Pac-Man map, but here is the actual right here. You see this? This is the format that I offered them and they ran away from. So Jerry, if you think you can do this, if you think you can actually face me in this kind of debate right here, as outlined here, you shoot me an email, mctoon@mctoon.net. It's in my channel description. It's not that difficult to find my email address. But right here, this is it. You want to have a look. But the essence is, I'll show you the essence. Right, go away. There we go. Is right here. The structure of the debate format right here. Experiment debate right here. It's on one of the topics that we did on the trip. Team A, 10 minutes. You present your hypothesis using your model. This is your model. And then using your model, you compute the consequences. You give us a prediction. So if the experiment is the distance between the lines of longitude, this will output a distance, some number of meters, for example, would be what's output from this between 2 points. And so on our trip, we did measure between 2 points of longitude. And so you would output the number from this. Okay. That's team A. Team B does the same thing. So one uses the globe, one uses flat Earth. And then we go and we publish the values that we measured. And then team A compares the measurement to the computation. Team B does the same thing. Right? Then team B, we reverse this, then gets a response. You get to respond to their hypothesis computation comparison. And then team A does the same thing, followed by 20 minutes open discussion on that particular topic. Whole thing 70 minutes. Now, what this will require is that you put together a model. And numbers are part of it. And so I give the link here to Richard Feynman talking about it. I reference Karl Popper's The Logic of Scientific Discovery. You're welcome to go read that. That's how you actually do science. And so this is the outline of the experiment, or the debate. So if you can't handle it, I understand. I would not be surprised if you can't handle it. So anyway, I'm not scared at all. This is a basic scientific debate. You do science. So that's it. Anyway, you let me know. Let me know if you've got the cojones, because Ronnie and Jason don't. They don't. Anyway, Dick Wayne's song coming up, everybody. This is a premiere never seen before. Super excited. Thank you, Conspiracy Music Studios, for this custom version of this song. And everybody, I hope you enjoy Dick Wayne.
He's the hero none of us needed. The scholar of zero, the sage of whatever. Ladies and gentlemen, give it up for Dick Wayne! Doesn't set, it's always in the sky. Water's perfectly flat, don't ask me why. Gas can't form balls, that's just fake. Gravity's not science, give me a break. Define math, you eyeball it, bro. 5 divided by 0's 5, don't you know? I don't care, that's just what I say. Science is religion in a different way. Show me a ball of gas on Earth. You can't have a ball of gas at all. Mass don't attract mass, that's insane. 1 times 1 equals 2. Dick Wayne! You want the truth? I'll tell you plain. I got a little trouble in the brain. I start to read, no problem there, but I pass out cold in the